the sun sinks low, painting the horizon in hues of gold and rose. Daylight gently yields to dusk. The air cools and a hush falls, as if the world is exhaling after the long day. High above, the sky deepens from blue to indigo. A few stars timidly appear. First one or two, then a dozen. In the west, a brilliant evening star, which is in truth the planet Venus, glimmers against the fading orange light, a lone beacon greeting the night. Soon the colours near the horizon dim to purple and then to the blue-black of night. The canopy of heaven, now free of the sun's glare, begins to reveal its countless gems. Night falls gently, and the sky becomes a velvet canvas of deepest blue and black. Countless stars awaken, strewn across the darkness with a soft silver glow. There is a profound stillness in this moment, as if the universe itself is holding its breath. Each pinpoint of light above has travelled years, decades, even centuries to reach your eyes. A silent journey ending in a delicate twinkle. Under this expanse of stars, the weight of the day lifts away. A calm wonder washes over you, replaced by a sense of infinite space and timelessness. In this tranquil darkness, the Milky Way stretches overhead like a pale mist. It's a river of stars flowing across the sky, a hazy band of light that our ancestors gazed upon in awe. From a quiet hilltop or a remote lakeshore, far from city lights, the view is breathtaking. A ghostly arch, studded with tiny diamond sparks. The night air is cool and carries only the subtle chorus of crickets and the rustle of a breeze, sounds that accentuate the vast silence of the stars. Beneath this celestial dome, you feel both tiny and deeply connected to something immeasurably grand and ancient. For thousands of years, humans have tilted their heads back to contemplate those twinkling mysteries. In the glow of a campfire or the stillness of a desert night, they wove stories about the lights above. The sky became a map of tales, gods and heroes, animals and legends, written in starlight. Each culture drew its own shapes between the stars, finding patterns and meaning where there are, in reality, only distant suns. In the quiet of night, imagination awakened. The dome of stars was a canvas on which hopes and fears were painted. The same stars that inspire scientific curiosity in us inspired comfort and wonder in them. High above, one of the most familiar constellations emerges, Orion, the hunter. Its pattern is clear. A trio of stars in a row form Orion's belt, and other bright stars mark his shoulders and knees. The ancient Greeks imagined Orion as a mighty hunter giant, placed in the sky by Zeus. They saw him drawing his bow, forever chasing the celestial bull Taurus across the heavens. If you trace Orion's outline, you can almost picture his form, striding boldly through the winter night. To the Greeks, these stars were a memorial of a hero. To us, they are a beautiful grouping that returns with each winter, evoking the still, cold nights of the year's dark season. Just near Orion's shoulder is a tiny cluster of stars like a sprinkle of fine dust, the Pleiades, or Seven Sisters. On a dark night, most people see 6 stars clearly. The 7th is faint, often requiring averted vision to glimpse. In Greek lore, these were the 7 daughters of the Titan Atlas, pursued by Orion's love. To save them, Zeus set them gently in the sky. Orion still chases them each night, but the god's intervention means he will never reach them. Cultures around the world also saw 7 in this cluster and created their own stories. To the Japanese, they are Subaru, meaning unite, a symbol of unity and togetherness. In many indigenous Australian stories, they are a group of young girls or sisters, and a hunter, often represented by Orion, follows them similarly. It's remarkable that peoples separated by oceans and centuries looked up and saw such similar visions in those stars. Across the world, others looked at Orion and saw different shapes. In China, Orion's pattern was part of a broader constellation of a great white tiger, and also associated with a legendary hero. In India, the same stars were seen as a stag or as parts of different asterisms in their own sky law. The patterns we see aren't the only ones. They exist in the human mind. Yet it is the instinct of people everywhere to find familiarity in the heavens. In the southern hemisphere, the skies shift. There, a famous constellation is not drawn by connecting stars, but by noting the darkness between them. The Aboriginal Australians see the emu in the sky, a great bird formed by the dark rifts of the Milky Way's dust clouds. On a clear winter night in Australia, the Coalsack Nebula, a dark cloud near the Southern Cross, becomes the emu's head, and the thick starry band outlines its body. This emu in the sky signalled important seasonal events. When it stood in a certain position at dusk, it was time to gather emu eggs. Even the absence of starlight, the black of the cosmic cloud, was woven into a useful guide. How gracefully ancient observers integrated every aspect of the night sky into their lives and culture. Meanwhile, in ancient China, the misty band of the Milky Way was known as the Silver River, a celestial river that separated 2 lovers. They told the tale of the weaving maiden, the star Vega, and the cowherd, the star Altair, who fell deeply in love. As punishment for neglecting their duties, the lovers were placed on opposite sides of the Silver River, able to meet only once a year on the 7th night of the 7th lunar month. On that night, it's said a bridge of magpies forms across the Milky Way, so the lovers can reunite for a few precious hours. Whenever Vega and Altair shine high in the summer sky, people in China remember this story of devotion and reunion. Such love stories set among the stars gave hope and romance to those gazing upward on summer nights, watching the sky slowly turn. Other cultures, too, found meaning in that gauzy Milky Way band. The San people of southern Africa tell of a girl who threw ashes from a campfire into the sky to help a lost friend find his way in the dark. Those embers became the Milky Way, a powdery, glowing path to guide everyone at night. The Inca of the Andes saw the Milky Way as a great river, and they identified dark constellations formed by its dust clouds, shapes of animals like the llama, believing these sky animals watched over their earthly counterparts. Across Europe, the Milky Way was often called the Road of St. James, or a Road of Souls. Everywhere, people looked up and saw a luminous band uniting horizon to horizon and felt it must be significant. A road to heaven, a spilled divine drink, a trail of cosmic story. The interpretations differed, but the sense of wonder was the same. One poignant tale from the Navajo tradition imagines the very creation of the starry sky. In the beginning of time, first man took glistening crystals and carefully placed them into the heavens, designing patterns that would guide and inspire. Slowly and deliberately he worked, positioning each star with purpose. But nearby, the coyote grew impatient. Annoyed by the slow progress, Coyote gathered up the remaining stars intended for the sky and flung them out of the blanket in a great arc. The sparkling stones scattered randomly across the firmament. where they clustered thickly became the Milky Way, and the careful constellations first man had already set were now joined by countless others thrown haphazardly. First man was dismayed, but it was too late. The sky had been seeded with both order and chaos. For the Navajo, this story explained why some stars form recognizable patterns while others seem strewn without design. Even in Coyote's mischievous act, there was beauty. The entire night sky, planned or not, became a vast, glittering tapestry. The lesson endures that the universe is a mix of that which we can understand and that which remains mysterious. Not all celestial stories were of heroes and animals. Some constellations honored everyday things, a plough or Big Dipper in many cultures, a celestial ship in ancient Egypt, a great bean jar in some African lore. The Big Dipper's 7 bright stars were seen as a big bear by Native Americans and as a wagon or plough by Europeans. To the Chinese, those stars formed the northern bushel or a governmental chariot. Yet one star remained fixed, Polaris, the North Star. All the other stars of the northern sky appear to wheel around this one point. For centuries, Polaris has been a steady beacon. Navigators and travellers used it to find north on clear nights. It sits nearly above Earth's North Pole, so unlike the rest, it neither rises nor sets, but stands guard in the same spot nightly. Imagine the relief of travellers in ancient times, under unfamiliar skies, to find Polaris and know their direction. This trustworthy star earned many names: Ship Star by the Phoenicians, Star of Guidance by desert nomads. By whatever name, it was a pin in the celestial map that helped humans chart their courses on Earth. Opposite the Big Dipper, on the northern sky's wheel, is a zigzag of 5 stars. Cassiopeia, the Queen. This constellation, shaped like a wide W or M, depending on its orientation, carries a story of vanity and consequence. Cassiopeia was said to be a beautiful queen in Greek myth who bragged she was more lovely than the sea nymphs. As punishment for her pride, the gods placed her in the heavens on her throne, but condemned her to circle the pole forever. In the course of each night, and over the year, Cassiopeia turns upside down when she is below Polaris, an eternal reminder of her boastfulness. Yet her 5 bright stars are a welcome sight. On crisp autumn and winter evenings in the north, Cassiopeia's elegant W glitters high opposite the Big Dipper. Together with Polaris, these circumpolar stars never set for many observers. They whirl around and around, keeping watch through the night and through the seasons, reassuring in their permanence. Those early stargazers likely felt comfort in seeing the same star patterns return each season. The heavens were a grand clock, marking the passage of time and the cycle of the year. When the scorpion-shaped pattern of Scorpius rose in the warm summer evenings, hugging the southern horizon with its graceful curl of stars, it signalled the peak of summer's heat. When mighty Orion climbed before dawn in late autumn, it was a herald of winter coming. Each constellation's arrival and departure was noted and celebrated. They were the glittering calendar and compass. The sky and earth moved together in a sacred rhythm. Each year, the familiar cycle of stars reassured people that while times and generations change, the cosmic order endures. Under the same sky in different eras, different peoples felt the same sense of wonder. They all saw the dome of stars arching overhead and told stories to make sense of it all. It didn't matter if they spoke different languages or lived on opposite sides of mountains and oceans. The stars were a common heritage, twinkling above everyone without discrimination. In the vast silence of night, Our ancestors projected their dreams and wisdom onto the heavens, finding comfort in believing the sky was filled with stories and watchful guardians looking down. Now, let us gently drift away from our home planet and journey outward into space. Above the atmosphere, the sky turns from blue to pitch black, and the stars no longer twinkle. They shine with a steady, untwinkling light in the void. Below us, Earth shrinks into a glowing blue marble, half in day and half in night. Ahead, the moon and planets beckon like beckoning lights. We embark on a cosmic voyage in our imagination, moving faster than light, to visit the wonders we have been contemplating from afar. Earth's constant companion, the moon, drifts through its phases overhead each month, serenely cycling from new to full and back. Many nights, its gentle glow has lit paths for travellers and stirred the hearts of poets. When full, it bathes the ground in silver, casting soft shadows. When a crescent, it hangs like a delicate cradle in the twilight, heralding night's approach. Near Earth's polar regions, the night sky sometimes comes alive with rippling colour. The aurora borealis and aurora australis, the northern and southern lights. Under these auroras, curtains of green, purple, and red light dance silently across the stars, as if the sky itself were breathing in colour. Some cultures saw the spirits of ancestors in these lights. Scientists learned they arise from the solar wind, interacting with Earth's magnetic field and atmosphere. But knowing their cause does not diminish their magic. Standing beneath an aurora's shimmering drapery, one feels as though the heavens have donned a living veil. Even on our home world, the cosmos reaches down to paint the sky with wonder, linking us to the sun's unseen energy and reminding us that Earth's environment is intimately connected to celestial happenings. Even rarer are the eclipses, when the sun, moon, and Earth align in a straight line. During a total solar eclipse, daylight fades in an eerie hush as the moon's shadow races across Earth's surface. Birds fall silent and return to roost. Flowers may close as if night has come, and temperatures drop noticeably. The sun becomes a black disk in the sky, surrounded by a pearly white crown, the solar corona, visible only when the brilliant face of the sun is completely covered. It is a sight both unnerving and sublime. For a few minutes, day turns to deep twilight, and bright stars and planets pop into view in the daytime sky. Then, in a breathtaking moment, the sunlight returns like a sudden dawn. A lunar eclipse, by contrast, happens on a full moon night when Earth's shadow slowly creeps across the moon's face. The bright lunar disk grows dim and then usually turns a coppery red when fully eclipsed. Illuminated only by sunlight refracted through Earth's atmosphere, casting the combined glow of all the world's sunsets and sunrises onto the moon. Ancient peoples often feared eclipses. They imagined dragons or demons devouring the sun or moon, or thought it an omen of great change. Today, we understand these alignments with precision, and many travel long distances for the privilege of witnessing them. During an eclipse, whether solar or lunar, one cannot help but feel the clockwork of the heavens in motion. These events are tangible demonstrations that we live among moving celestial bodies, casting shadows on one another. Eclipses remind us that we inhabit a system of moving parts, and for a brief time, those parts can create stunning spectacles that unite sky watchers in awe and humility. Now we leave Earth's vicinity behind and venture farther outward. Past the orbit of the Moon and beyond, we travel into the realm of the planets. The first planet we encounter on our journey outward from the Sun is Mercury. Closest to the Sun, tiny Mercury is a world of extremes. It's a small, rocky globe that bears a strong resemblance to our Moon. Heavily cratered, airless, and stark, Mercury races around the Sun in just 88 Earth days, zipping faster than any other planet, which is why the ancients named it after the fleet-footed messenger god. Yet despite its speedy year, Mercury rotates slowly. A single day-night cycle lasts about 176 Earth days. One side of Mercury can broil in searing sunlight, while the other lies in deep, long night. On Mercury's sunward side, the surface is baked to temperatures hot enough to melt lead. At night it plunges into frigid cold, hundreds of degrees below freezing. There is virtually no atmosphere to distribute the heat or soften the sky's blackness. It's a world of harsh sunlight and black shadows. Because Mercury stays so near the Sun, we rarely see it. It's often lost in solar glare. Only at certain twilight times might one catch a fleeting glimpse of Mercury low on the horizon, a tiny dot of light that soon follows the Sun down. In the silence of space, we glide close to this little planet and see a landscape covered in craters and long cliffs. It's as if we're flying over a charcoal grey moon, pockmarked by eons of impacts. There are no winds or rains here. The records of ancient asteroid strikes remain etched on the surface. In the absence of air or sound, Mercury circles the Sun in quietude, locked in a perpetual stillness, broken only by the blazing dawn every second mercurial year. After a moment of marvelling at this little world, so close to the Sun, yet so isolated, we press onward. Beyond Mercury lies Venus, shrouded in thick, reflective clouds. To the eye, Venus is the brightest of planets, a gorgeous evening star that appears soon after sunset in the west, or a morning star preceding sunrise. For that brilliance and its steady, beckoning presence, ancient cultures associated Venus with love and beauty. The Romans named it for their goddess of love. It's easy to see why. Venus gleams like a jewel at dusk or dawn, often the first star to appear as day fades. But beneath its pearly white cloud layers, Venus is a tale of extremes. As our journey takes us into the cloud tops of Venus, we find an atmosphere tens of kilometers thick and churning with hurricane-force winds. Deeper down, the temperature rises and the pressure mounts. By the time we descend virtually to the surface, we discover a hellish landscape, a bone-dry furnace of a world. Venus's surface is hot enough to melt lead, about 460 to 860 degrees, due to a runaway greenhouse effect caused by its dense carbon dioxide atmosphere. The pressure at ground level is crushing, over 90 times Earth's pressure, like being 900 meters under the ocean. The clouds high above are not water vapor, but droplets of corrosive sulfuric acid. No gentle breezes exist here, only a toxic, high-pressure oven. And yet, from above, none of this harsh reality is visible. We see only a smooth, cream-coloured blanket of clouds, hiding the inferno below. Through a telescope from Earth, Venus shows phases like the Moon. At times a slender crescent, at times gibbous, reminding us that it orbits closer to the Sun than we do. In some ways, Venus is Earth's twin, similar in size and gravity, likely made of similar materials. But somewhere in its history, it took a divergent path and became a cautionary tale of a greenhouse world. As we leave Venus behind, we note the irony that this gorgeous, radiant light in our sky conceals one of the most inhospitable surfaces imaginable. The ancients who adored Venus as a bringer of morning and evening light could hardly have guessed the brutal truth hidden beneath those enticing clouds. Beyond Venus, at just the right distance for liquid water and life as we know it, lies Earth, our home. We turn back for a moment to consider our own planet from this perspective. Seen from space, Earth is a sapphire blue sphere swirled with white clouds and brown-green land masses. It is, as far as we know, the only oasis of life, a living world teeming with oceans and forests, storms and seasons. Earth orbits the Sun at an average distance of 150 million kilometers, completing the circuit in 1 year. Its axis is tilted, which gives us seasons, a graceful annual dance of spring blossoming, summer thriving, autumn harvesting, and winter resting. Travelling alongside Earth is its moon, a constant companion that gently tugs our tides and lights our night. From the cosmic vantage, Earth's atmosphere is a fragile, thin glow on its limb, the only thing separating life below from the cold vacuum of space. For all our explorations so far, we have yet to find a place quite like Earth. It reminds us how precious and singular our world is amid the vast darkness. And yet, from out here among the planets, Earth itself is just another moving light, a pale blue dot against the black. Before we venture farther, let's recall that famous image taken by Voyager 1 as it departed the solar system. Earth, a tiny point of blue caught in a sunbeam, less than a pixel in size. In that speck, that pale blue dot, is every story, every life, every dream humanity has known. The thought can be at once humbling and heartening. With a mix of reluctance and curiosity, we bid our homeworld goodbye for now and journey outward, carrying its lessons and its light in our minds. Mars, the red planet, comes next. Even from Earth, Mars has a distinct rusty colour, earning it the name of the god of war in ancient times for its blood-like hue. We approach Mars and find a smaller world than Earth, blanketed in iron-rich dust that gives it that ochre tone. Up close, Mars reveals itself as a cold desert planet. Its skies have a salmon-pink tinge during the day, tinted by fine dust suspended in the thin atmosphere. We soar over canyons and extinct volcanoes that tower above the Martian plains. The tallest, Olympus Mons, is the height of 3 Everests stacked. The largest volcano in the solar system, now long dormant under a sky that no longer has rain. Near the poles, we see caps of gleaming white, frozen water, and carbon dioxide ice that shrink in summer and grow in winter. Dust storms occasionally arise, and some can grow to engulf the entire planet in a beige haze for weeks. Despite these dramas, Mars is a quiet world now. No obvious life stirs, no verdant fields or vast oceans. Only the evidence that long ago water flowed in river channels that are now dry. Ancient skywatchers looked at Mars, wandering against the backdrop of stars since planets move, and noting its red colour, associated it with conflict and portent. Yet today, as we skim over its cratered fields and grand canyons, we know Mars as a place of solitude. Still, it captivates us. We have sent robotic emissaries, rovers and landers, to touch its soil and read its history written in rock. These machines have found signs that Mars was once warmer and wetter. They have seen rounded pebbles that were tumbled in ancient streams, detected minerals that form in water, and even tasted traces of complex organic molecules in Martian soil. The possibility that life might have flickered on Mars eons ago, perhaps when it had lakes and volcanoes active, remains one of the profound unanswered questions. As stars begin to appear in the Martian twilight sky, one of those stars is Earth, shining softly above the horizon of this alien world. How extraordinary, we think, that now humans on Earth and robots on Mars can simultaneously look toward each other across space. Mars stands as a distant cousin of Earth, a smaller, quieter planet with its own stark beauty. It hints at what our world could have been in another circumstance, and it challenges us to learn its lessons. We leave the red planet with a sense of kinship, for we too are made of rock and sun-touched soil, and continue outward. Beyond Mars stretches the asteroid belt, a broad zone of rocky fragments left over from the solar system's formation. We find ourselves amid countless irregular rocks and boulders ranging from tiny pebbles to dwarf planet-sized series. These asteroids tumble in silent orbits around the Sun, sparsely distributed. Despite what science fiction might depict, they are so far apart that our spacecraft easily navigates through. Still, collectively they form a tenuous ring girdling the Sun like an ancient broken necklace. We glide among a few of these asteroids briefly. Some are pocked with craters. Some are essentially piles of rubble barely held together by gravity. Occasionally, two asteroids gently collide or a piece breaks off, creating smaller fragments. Once in a while, an asteroid's path is perturbed, perhaps by Jupiter's gravity, and it heads inward toward the Sun. These are the meteoroids that sometimes cross Earth's path, becoming shooting stars, or meteorites if they reach the ground. Bits of the asteroid belt paying our planet a visit. After marvelling at these primitive rocks, pieces of the primordial solar nebula that never formed into a planet, we press on. Beyond the asteroid belt's subtle haze, the giant of worlds awaits. Farther out lies Jupiter, the king of planets. As we approach, it shines like a brilliant cream-coloured star, brighter than any we've yet seen, aside from Venus. With a small telescope from Earth, one can see 4 bright moons near Jupiter, lined up like a miniature solar system. Indeed, as we draw closer, Jupiter looms enormous, more than 11 times Earth's diameter. It's a colossal sphere of swirling clouds and bands, a gas giant with no solid surface under those dense skies. Its most famous feature, the Great Red Spot, comes into view, a raging storm twice the width of Earth, embedded in Jupiter's southern hemisphere. This storm has been observed for centuries, a persistent cyclone of peach and brick red hues, churning in a sea of white and ochre clouds. All around the red spot, other storms and eddies dot the cloud bands. Lightning flashes deep within the cloud tops, illuminating momentary patterns in swirling ammonia and water vapour. Jupiter is adorned with alternating dark belts and light zones that wrap around it like stripes. As our spacecraft coasts just above the cloud tops, we witness these bands flowing east-west at different speeds, driven by powerful jet streams. The planet rotates amazingly fast. One day is about 10 Earth hours, causing the clouds to spread into broad bands from the rapid spin. Jupiter has no firm ground. It's mostly hydrogen and helium gas, becoming denser and hotter toward the core. We realize we are gazing at the roiling surface of a star that never quite ignited. Jupiter emits more heat from its interior than it receives from the distant sun, energy left from its formation. Orbiting Jupiter are more than 70 moons. 4 are large enough to be worlds of their own, the Galilean moons, discovered by Galileo in 1610 with his early telescope. We make a brief detour to appreciate them. First, volcanic Io, closest to Jupiter. As we fly over Io's mottled yellow-white surface, we see active volcanoes spurting fountains of sulfur and sulfur dioxide frost. Lakes of molten sulfur dot its landscape. Io is the most volcanically active body in the solar system, its interior continually flexed and heated by Jupiter's immense gravity. Next, Europa, an ice-covered moon slightly smaller than Earth's moon. Europa's surface is smooth, crisscrossed by rusty brown cracks and streaks. Beneath its water ice crust, scientists strongly suspect an ocean of liquid water exists, kept fluid by tidal heating. We imagine for a moment descending through that ice and finding a dark ocean below, perhaps 100 kilometers deep, perhaps warmed at the bottom by hydrothermal vents. Could some form of life swim in Europa's hidden sea, under an eternal starry night of ice? It is a tantalizing thought. Moving outward, we come to Ganymede, largest of Jupiter's moons, and indeed the largest moon in the solar system, even bigger than Mercury. Ganymede shows regions of old, cratered terrain and somewhat younger, grooved ice plains. It has its own magnetic field, indicating a complex interior, maybe a hidden ocean as well. And then Callisto, the outermost large moon, ancient and heavily cratered, essentially a preserved remnant of the early solar system, its surface never resurfaced by big geological activity. These 4 moons orbit Jupiter in a rhythmic dance, their gravitational tugs locked in resonance. They present a microcosm of variety: fire and ice, rock and ocean, almost a mini solar system. In myth, Jupiter, or Zeus, was king of the gods, and fittingly, this planet, with its majestic retinue, rules the outer solar system with a gravitational might that shepherds asteroids and comets. Indeed, Jupiter likely protects Earth from some cometary intruders, its gravity often flinging them away or swallowing them outright. We linger a moment longer, watching Jupiter's moons cast tiny black shadows on their giant parents' cloud tops, then proceed outward. As we leave, Jupiter recedes like a huge marbled sphere behind us, quietly reigning over its domain with stately grace. Saturn appears next, a golden globe adorned with ethereal rings. Even from afar, Saturn's rings make it one of the most breathtaking sights in the solar system. In the night sky seen from Earth, Saturn shines with a steady, honey-coloured light, not as bright as Jupiter, but unmistakably beautiful. As our spacecraft nears Saturn, the rings resolve into countless individual particles, billions of chunks of ice and rock, ranging from pebbles to boulders, all orbiting in a flat plane. Through early telescopes, centuries ago, Saturn confused observers. Galileo first drew it as a planet with ears, unable to discern the rings clearly. Now we see them in their full glory. Broad, flat loops encircling Saturn's equator, shining brightly as they reflect the distant sun. They are divided into several main rings with darker gaps, like the notable Cassini division. Saturn itself is a gas giant slightly smaller than Jupiter, but still over 9 times Earth's diameter. It's less dense than water. In fact, if there were a bathtub big enough, Saturn would float.
Its cloud bands are more subtle than Jupiter's, gentle butterscotch and grey hues, with occasional white storms that appear and dissipate. Saturn rotates quickly, a day about 10.7 hours, and is bulged at the equator due to its spin. As we drift just above the rings, we notice the sunlight glinting and scattering, creating an almost iridescent halo. If one were to stand on Saturn's cloud tops, impossible in reality, but in imagination, the rings would cast shadows, sometimes a thin line across the planet when the sun hits them edge on, other times broad swathes shading the cloud tops when seen at an angle. Saturn's rings are relatively thin, only tens of meters thick in places, despite spanning hundreds of thousands of kilometers in diameter. The particles gently collide and rebound, confined into waves and ringlets by the gravity of Saturn's numerous moons, which act as shepherds. Speaking of moons, Saturn has a great many, more than 80 identified. One stands out: Titan, Saturn's largest moon, and the second largest moon in the solar system. Only Ganymede is bigger. Titan is enveloped in a thick, smoggy orange atmosphere, so dense and cold that it has clouds, rain, and lakes, not of water, but of liquid methane and ethane. Beneath its golden haze, Titan's surface is sculpted by rivers and lakes of hydrocarbons and possibly cryovolcanoes that erupt water-ammonia mixtures. It is an Earth-like landscape in the deep freeze, with a dense atmosphere that would allow a human to walk on Titan without a pressure suit, though certainly needing warmth and oxygen. We imagine briefly standing on Titan's surface. The sky is a dull orange-brown. Saturn might be a fuzzy ball in the sky visible at all through the haze, and a light drizzle of methane might be falling onto alien dunes. How quietly extraordinary it is that nature can produce something so familiar. Rain, rivers, lakes, in a place so otherwise unearthly. Other Saturnian moons each have their own surprises. Enceladus, a small ice moon, gleams bright and, as discovered by the Cassini probe, has geysers of water vapour and ice particles actively jetting from its south pole, feeding material into Saturn's E-ring and hinting at a subsurface ocean. Within Enceladus, there's Iapetus, half of which is dark as coal and the other half bright as snow, with a mysterious ridge running along its equator, making it look like a walnut. There's Mimas, with a crater so large it makes the moon resemble the Death Star from fiction. Saturn's collection of moons is like a cabinet of curiosities, each unique, contributing to the overall beauty of the system. Named for the ancient god of time, Cronus, father of Zeus, Saturn drifts along on its stately 29.5-year orbit around the Sun. As we take one last look back, Saturn, with its rings, appears as a delicate jewel, set against the black velvet hair of space. It embodies a silent, timeless beauty, the kind that makes one's heart ache slightly, without knowing why. We leave Saturn with reluctance, but new wonders beckon in the distance. Beyond Saturn, the planets grow dimmer and more mysterious. The next planet outward is Uranus, an ice giant with an aquamarine hue. Uranus is unique in that it's tipped over on its side. Its axis is almost pointing at the Sun. As we approach Uranus, we notice it's a faint teal-coloured disk against the stars. To the naked eye, from Earth it's barely visible, needing a telescope to be seen clearly. This strange sideways planet rolls around the Sun like a sleepy sphere, taking 84 years to complete one orbit. Its atmosphere is mostly hydrogen and helium, with a trace of methane that lends the soft blue-green colour. Unlike the boiling cloud patterns of Jupiter or the rings of Saturn, Uranus's features are subtle. On occasion, telescopes or passing probes have caught sight of faint cloud bands or storms, but for the most part, Uranus looks smooth and placid. Yet beneath that calm visage, dramatic things happen over long periods. Because of Uranus's extreme tilt, each pole gets around 42 years of continuous sunlight, followed by 42 years of darkness. At the time of our imaginary visit, say the northern hemisphere is slowly coming out of a decades-long night into a cold dawn. Uranus has a delicate system of rings, narrow and dark, discovered in the 1970s when they blocked starlight during an occultation. They are not as showy as Saturn's, but they encircle the planet in equatorial loops that are also tilted with Uranus's sideways orientation. The planet is orbited by more than 24 moons, most of them small and composed of ice and rock. They bear names from Shakespeare and Pope, rather than classical mythology: Oberon, Titania, Ariel, Miranda, etc., courtesy of the discoverer William Herschel and his son. One moon, Miranda, looks particularly odd. It has huge chevron-shaped grooves and cliffs, possibly from having been shattered and reassembled by gravity multiple times. As we glide by Uranus, we recall that it was the first planet discovered in historical times, in 1781, by Sir William Herschel. At first, Herschel thought it a comet. Only later was it recognised as a new planet, expanding the known bounds of the solar system for the first time in modern history. Imagine the wonder that news must have brought. Beyond Saturn, a whole new world lurking in the sky, previously mistaken for a star. Uranus moves through the darkness in a slow, stately path, a remote world lit by a sun so distant that it appears only as a brilliantly bright star from Uranus's cloud tops. We take in the serene, muted cyan view of this distant ice giant, appreciate the quiet mystery it holds, and then press on to the next and final planet. Farther still is Neptune, the outermost major planet, shining a rich azure blue. Neptune is a twin of Uranus in size and composition, another ice giant, but it has a more vibrant personality. As our craft nears Neptune, we see a deep blue orb with wisps of white clouds. Neptune's atmosphere, though cold and thin, is active. The Voyager 2 probe, in 1989, revealed a great dark spot, a storm similar to Jupiter's red spot, and swift winds, among the fastest in the solar system, tearing around at over 1,000 miles per hour. The dark spot has since disappeared, as observed by the Hubble telescope, but others have appeared. Neptune's weather is changeable. High, thin, cirrus clouds of methane ice are seen casting shadows on the layers below as they race around. The brilliant blue colour, reminiscent of a calm ocean on Earth, led to naming it after Neptune, the god of the sea. It truly looks marine and majestic, an ocean-coloured guardian at the edge of our solar neighbourhood. Neptune has a collection of moons as well, at least 14 known. The standout is Triton, a moon nearly as big as Pluto, with a frigid surface of nitrogen ice. Triton is unique. It orbits Neptune in the opposite direction of Neptune's rotation, a retrograde orbit, suggesting it was likely a captured Kuiper Belt object. As we fly over Triton, we see a strange, cantaloupe-like terrain and smooth volcanic plains where slushy ice may have erupted long ago. Voyager 2 observed geyser-like plumes on Triton, nitrogen gas with dust particles, active geology in the far cold. Triton's thin atmosphere and pinkish nitrogen frost make it an eerie, distant cousin of more active worlds. It's possibly the coldest surface in the solar system, around minus 235 degrees Celsius. Other small moons whirl closer to Neptune, but they are dark and hard to observe. Neptune, like Uranus, was discovered in modern times, 1846. But unlike Uranus, its discovery was a triumph of mathematics and prediction. Astronomers noticed as Uranus was deviating from its expected orbit and inferred an unknown planet's gravity was tugging it. By calculating where this mystery perturber should be, observers found Neptune almost exactly where predicted. This was a profound validation of our understanding of gravity and the celestial choreography of the planets. Since Neptune's discovery, not even one Neptunian year has passed. The planet has completed about 3/4 of its orbit since 1846. At Neptune's great distance, about 4.5 billion kilometres, from the Sun on average, sunlight is weak, roughly 1/900 the intensity as at Earth. Daytime on Neptune is like deep twilight on Earth. The Sun is a small, bright white star in Neptune's sky, no longer an overwhelming brilliant disk. As we take our leave of Neptune, we reflect on the beauty of its isolation. This blue world circles in a vast, dark, silent orbit, seemingly lonely, yet we now know it is accompanied by a retinue of moons and rings, and bound by the same sun's gravity that holds the inner worlds. Neptune marks the conventional end of our solar system's planetary family, but our journey can continue outward still. Even beyond Neptune, our solar system stretches on. We enter the domain of icy dwarfs and comets, the Kuiper Belt, and farther out, the Oort cloud. Here, far from the sun's warmth, countless frozen bodies circle quietly. Pluto, once counted as the 9th planet, resides here in the Kuiper Belt as one of many dwarf planets. For decades, Pluto was just a dot in our telescopes, a tiny moving point of light on the photographic plates. But in 2015, the New Horizons spacecraft flew past Pluto and unveiled an astonishingly complex little world. We find Pluto a small, cold orb with a soft reddish-brown tint. Its surface is a mix of white, dark and orange areas. Most famously, it has a large heart-shaped region, unofficially called Tombor Regio, after Pluto's discoverer, Clyde Tombor. This heart is actually a vast plain of nitrogen ice, smooth and young, with no craters, indicating Pluto is geologically active even now. This plain, called Sputnik Planitia, is segmented like the cracked mud of a dry lake bed, except it's nitrogen ice, convecting slowly over time. To the west of the heart, great ranges of water ice mountains soar as high as 3 to 4 kilometres, their peaks capped with methane snow. In the dim sky above Pluto, the sun is distant, but still 100 times brighter than our full moon. It casts a faint daylight across the rust and white terrain. Pluto has its own moon, Charon, nearly half Pluto's size. In fact, Charon is so big compared to Pluto that the two act like a double planet system, orbiting a point in space between them. Charon's surface is grey and covered in water ice, and ammonia hydrates. It sports a large reddish cap at its north pole, possibly tholins, organic compounds, that escaped Pluto's atmosphere and coated Charon. Pluto and Charon are tidally locked, always showing the same face to each other, engaged in an eternal cosmic waltz. They circle their common centre every 6.4 days. If you lived on one, the other would hang fixed in your sky, never rising or setting. Out here, the sun is merely a brilliant star, providing a twilight level of illumination. When the sun sets, darkness is near absolute, broken only by starlight and the faint glow of Pluto's thin atmosphere, which during sunset and sunrise on Pluto would create a blue haze around the edge as New Horizons photographed. Pluto turned out not to be alone. It's part of a vast collection of frozen objects, scattered through the Kuiper belt, which extends thousands of kilometres beyond Neptune's orbit, are other dwarf planets such as Eris, which is about the same size as Pluto, Makemake and Haumea, an elongated, rapidly spinning world with a crystalline ice surface. Countless smaller, icy bodies inhabit this region, primordial remnants of the solar system's formation. Occasionally, two collide, or a pair gravitationally interact, and some are flung onto different orbits. Some plunge inward toward the sun, becoming what we know as comets. As we continue outward, the sun's influence wanes, but its gravitational grasp still extends. Beyond the Kuiper belt, at perhaps 50,000 times the Earth-Sun distance, far beyond our current position, lies the hypothetical Oort cloud, a spherical shell of trillions of, say, icy bodies that are too far to see, but whose existence is inferred. From this distant reservoir come the long-period comets, those that arrive unexpectedly from any direction, visit the inner solar system with a single glorious appearance, and then often depart forever, hurled back into the depths or captured into long orbits. Occasionally, one of these ancient ice wanderers from the Kuiper belt or Oort cloud is disturbed from its orbit and begins a long fall toward the inner solar system. As it nears the warmth of the sun, its frozen surface heats up and sublimates into gas, releasing dust and forming a luminous tail that can stretch millions of kilometres across space. In the night sky of Earth, such a visitor appears as a hazy star with a glowing head and a trailing veil, a comet, a celestial apparition, slowly drifting among the fixed stars. In ages past, people gazed at these sudden visitors with both awe and apprehension, often seeing dragons or divine omens in their mysterious tales. Today, we understand a comet to be a travelling iceberg from the solar system's edge. Yet when one graces our skies, science and myth meld into pure wonder. A bright comet is a cosmic gift, a reminder that our sun's family extends far into the cold and dark, and that occasionally a member of that distant family returns to light up our nights and spark our imagination. Sometimes even a visitor from another star wanders through. A recent example was a strange cigar-shaped object named Oumuamua that passed by the sun and then continued wordlessly back into interstellar space. At times, Earth itself plunges through the dusty trails left by ancient comets. When that happens, the night comes alive with meteors, shooting stars streaking across the sky. These brief flares of light are caused by tiny sand grain-sized bits of comet debris burning up as they hit Earth's atmosphere at tremendous speed. Every August, when Earth moves through the remnants of Comet Swift-Tuttle, we see the Perseid meteor shower. Every November, the Leonids arrive from the debris of comet Tempel-Tuttle. Ancient sky watchers often saw meteor storms as fireworks from the gods, or in some cultures, as sparrows dropping from the sky, or simply as blessings and omens. Nowadays we anticipate these showers like celestial festivals. One can lie back on a warm summer night and see dozens of meteors an hour during a good Perseid shower, each leaving a fleeting trail as silent as it is swift. As you watch, you might think that streak was a tiny pebble from a comet's path, giving its existence up in a last moment of beauty for us to enjoy. The shooting stars remind us that Earth is ploughing through space on its orbit, encountering leftovers of ancient comets. The cosmos is not static, it's dynamic and intertwined with our planet's journey. Our solar system, magnificent and varied, is but one tiny corner of a vast galaxy. Having toured the familiar planets, moons and small bodies around our sun, we now prepare to venture beyond the influence of our star. We have seen that even the solar system is huge. It took our swift imaginary craft quite some time to go from world to world. But now, the true enormity of space confronts us. Beyond the Kuiper belt, the sun slowly diminishes in apparent size. Eventually, we reach a point where the sun's gravity is no longer dominant over the tugs of other stars. That is the edge of the solar system, where the Oort cloud begins. Here, comets form a tenuous swarm, extending perhaps a quarter of the way to the nearest star. We continue outward. The sun becomes an especially bright star behind us, and the planets we visited are all lost in its glare. Our spaceship, like the real Voyagers 1 and 2, now truly enters interstellar space, the space between stars. Out here, the vastness is profound. The nearest star, Proxima Centauri, is over 4 light years away, about 40 trillion kilometres. Yet even in this seeming emptiness, we are not completely alone. Extremely sparse wisps of gas and dust drift in the interstellar void, and the bubble of charged particles from the sun, the heliosphere, has been left behind, replaced by the faint influence of the collective environment of our galaxy. If we look back now, with eyes that can see the invisible, we might detect a faint boundary shock, where the solar wind's influence ceased. The space between stars is quiet and dark, but not utterly empty. Our spacecraft carries with it a golden record on voyages, a greeting from humanity to whoever might find it eons hence. Those probes are now beyond the planets, sailing on into the galaxy. As we imagine following in their wake, we realise how far we have to go to reach even the next star. But let's speed up our journey, in imagination infinitely, so that we can travel the light years as easily as stepping over a stream. The stars of our Milky Way galaxy now beckon. We find ourselves in the realm of the stars, interstellar space. It is almost unfathomably vast. The stars that seemed packed densely in the night sky are separated by trillions of kilometres or more. If the sun were a grain of sand, the nearest star would be another grain of sand, perhaps 30 kilometres away. Yet here and there, in this void, we encounter an interstellar cloud, a nebula where gas and dust collect. These are stellar nurseries, the places where new stars are born. One of the most beautiful such places, seen from Earth near Orion's belt, is the Orion Nebula. To the naked eye, Orion Nebula is a faint smudge in the sword of Orion. But as we venture into it, it blossoms into a luminous cloud of gas and dust, glowing softly pink and purple. This vast stellar nursery is about 1,300 light years from Earth. Within it, hundreds of baby stars are taking shape in a cavern of molecular gas. Ultraviolet light from a few massive newborn stars at the nebula's centre causes the surrounding hydrogen gas to fluoresce like a neon sign, filling the region with a gentle rose and violet hue. We drift among the filaments and pillars of the Orion Nebula. It's cold here and tenuous. If we scooped the nebula gas into a box, it would be emptier than the best laboratory vacuum on Earth. Yet gravity is quietly at work. In denser knots within this cloud, protostars are coalescing. Some have formed disks around them, and in those protoplanetary disks, new planets may already be accreting, heralded by faint warm glows in infrared light. It's a cosmic nursery, hidden within the folds of a grand, diffuse cloud. In another corner of the sky lies an equally wondrous stellar nursery, known as the Eagle Nebula. Within it are vast columns of gas and dust, famously nicknamed the Pillars of Creation, captured in an iconic Hubble photograph. These pillars tower for light years, yet are relatively delicate, composed of cool hydrogen gas and dust, eroded into finger-like shapes by the intense radiation of young stars nearby. We guide our craft around one pillar's edge, where newborn stars, previously hidden inside, are starting to emerge, carving cavities in the column with their energetic starlight. The scene is of sublime grandeur, cosmic cliff faces, illuminated in ethereal blue-green light, dense globules at their tips where protostars hide like cosmic eggs. Eventually, these pillars will dissipate entirely, leaving clusters of bright new stars. Such images and locales reveal the artistic side of the cosmos, where the process of star-making creates beauty as a byproduct. We marvel at the sight, understanding why these nebulae captivate all who see pictures of them. They are nature's canvases, painted in stardust and light. All stars, even our sun, are thought to have been born in such nurseries. Often they form in clusters, dozens or hundreds of sibling stars condensed from the same cloud. For a time, these clusters remain together. We visited one earlier, the Pleiades, which are a relatively young, open cluster, whose stars share a common origin and are still loosely bound. Over hundreds of millions of years, many clusters disperse as their members drift away along the Milky Way. But some clusters, especially rich ones, can remain for much longer. As we move onward, we pass by a splendid cluster of stars, glittering like a pile of jewels in the black. This could be the Jewel Box cluster near the Southern Cross or the double cluster in Perseus. The stars in such clusters are physically associated, moving together through space. They're often hot and blue, shining intensely in their youth. It's a reminder that stars are often born in family groups, not in isolation, like lonely fireflies. Most stars are not solitary, like our sun. In fact, the majority of star systems in our galaxy consist of two or more stars bound together. These binary or trinary systems orbit their common centre of gravity, engaged in gravitational dances that can last billions of years. If we pause near a binary star system, we might witness a graceful pas de deux. Imagine two golden suns twirling around an empty point in space between them, locked in each other's influence, Some binaries are widely separated, each star living its life with plenty of personal space, while others are so close that they may transfer mass or even eventually merge. Through telescopes, some seemingly single stars reveal their dual nature. One famous example is Albireo, a star in the constellation Cygnus. To the naked eye, Albireo appears as one point of light marking the swan's head. But in a telescope, it splits into a stunning, colourful pair, one star amber gold and the other sapphire blue. They are a visual binary, though at a distance of about 400 light years from us. It's debated if they're a true gravitational pair or just an optical alignment. Still, many true binary systems show lovely colour contrasts and serve as cosmic showpieces. If there are planets around one star in a binary, the inhabitants would enjoy a double sunrise if the stars are close, or perhaps one sun rising as another sets if the stars are farther apart. The dynamics can be complex, but stable planetary orbits are possible in certain configurations, giving rein to the imagination. A sky with two suns, each casting its own shadow. How marvellous that would be. Binary and multiple star systems teach us that companionship is common in the heavens. Just as we have families and friends, stars too can have partners. Some embrace tightly, some keep a respectful distance. But many, if not most stars, are born and remain in pairs or groups. It's a cosmic reminder that solitude is not the only way. Even in the vast loneliness of space, there are relationships and dances being carried out over eons. Our journey now takes us further from stellar nurseries into regions where dying stars paint the sky. Eventually, every star exhausts its fuel. For a sun-like star, after billions of years it swells into a red giant. We encountered a hint of this fate when we noticed the star Betelgeuse glowing orange-red in Orion. Betelgeuse is a supergiant nearing the end of its life, so large that if it were placed where our sun is, its surface would extend past the orbit of Mars. Such swollen stars show us what our sun might become, though on a smaller scale, in about 5 billion years. In the far future, our sun will expand into a red giant, likely engulfing Mercury and Venus, and making Earth uninhabitable. In that distant era, our sun's light will turn reddish, and its surface will cool even as its overall size grows enormous. The solar wind will intensify and the sun will gently blow off its outer layers. When a sun-like star finally sheds those layers completely, what's left is a small, hot core, a white dwarf about the size of Earth. And the expelled outer gases form a glowing shell called a planetary nebula, named not because it has to do with planets, but because early astronomers with small telescopes thought these round gas shells resembled planetary disks. We visit one such planetary nebula. From a distance, through a telescope, it appears as a tiny, smoke ring-like cloud. Up close, we find it's an expanding shell of gas cast off by a dying star. One famous example is the Ring Nebula in Lyra. It looks like a ghostly torus of colourful gas. If we drift through the Ring Nebula, we'd see a football-shaped bubble of glowing material. The central white dwarf star that remains is extremely hot and emits intense ultraviolet light, causing the ejected gases to fluoresce in vivid colours, often greens from doubly ionised oxygen and reds from hydrogen and nitrogen. These nebulae are like cosmic butterflies a star's metamorphosis from a bloated red giant to a compact white dwarf, with a nebula as its discarded chrysalis shining briefly before dispersing into the interstellar medium. Eventually, that material will mix with other gas and contribute to forming new stars and planets, recycling the star's elements. In fact, our Sun and Earth are made partly of such stardust from previous generations of stars that died long before the solar system was born. As we marvel at the delicate beauty of a planetary nebula, perhaps shaped as an hourglass or a ring or a bipolar form, we realise we are witnessing both an ending and a beginning. The end of a star's life as it was, and the seeding of space with new, raw material. For stars much more massive than the Sun, the finale is even more dramatic. A star, say 8 or 10 times heavier than our Sun, lives a shorter, more furious life. It fuses heavier and heavier elements in its core until iron is produced. And iron cannot release energy by fusion. In a matter of seconds, the star's equilibrium fails. The core collapses under its own weight until nuclear forces halt it, and then the core rebounds. The star's outer layers are blown off in one of the most cataclysmic events in the universe, a supernova explosion. We do not witness one up close on our journey, for our safety, thankfully, but the evidence of such events is scattered throughout the galaxy. We choose one particular destination to understand this: the Crab Nebula in Taurus. The Crab Nebula is the remnant of a supernova recorded by Chinese astronomers in July of the year 1054 AD as a guest star that shone in the daytime sky for weeks. When we arrive at the Crab Nebula, we find a vast expanding cloud of filaments spread across 11 light years. It's a beautiful but chaotic scene. Threads of pink and orange gas, the expelled stellar material, intertwined with eerie turquoise haze, emitted by electrons spiralling in magnetic fields. This tangle of gas is moving outward at thousands of kilometers per second. In the center of the nebula resides a pulsar, the tiny core left from the explosion, now a rapidly spinning neutron star. This pulsar is about the size of a city, maybe 20 kilometers across, but contains more mass than our Sun. It spins 30 times a second, flashing beams of radiation, like a lighthouse. Each time its beam sweeps Earth, we detect a pulse of radio waves and light. Here in the nebula, we can actually see the pulsar energizing the gas around it, creating an ethereal bluish glow of synchrotron radiation. The Crab Nebula is not quiet. It's a scene of ongoing energy, input from the pulsar wind, a bit like a cosmic storm that never ends. And yet, it's also astonishingly serene in its own way, floating in the silence of space. Supernova remnants like this are the seeds of the next cosmic generation. In their guts, the massive stars forged heavy elements: oxygen, carbon, silicon, even iron. And the supernova forged elements heavier than iron, like gold, silver, uranium, in its fleeting fury. All these ingredients are now cast into space, mixing with the interstellar medium. One day, some of these atoms might become part of a new star, a new planet, or even a new living being. We reflect on the fact that our bodies contain atoms that were made in just such supernova explosions billions of years ago. The iron in your blood was created in a massive star and liberated in a supernova. The calcium in your bones, the oxygen you breathe, elements beyond hydrogen and helium, were synthesized in stars and distributed by their deaths. Physicist Joni Mitchell Put it well in poetic terms, we are stardust. We literally are. As we journey past the Crab Nebula, we acknowledge the sorrow and beauty of a star's death, an end that is also a cosmic rebirth, showering space with the building blocks of planets and life. There is a kind of quiet immortality in these cosmic processes. A star perishes, but its remains fertilize the galaxy with new material. In time, that material will help form new stars, new planets, and maybe new life. Even black holes, often seen as the universe's monsters, have their role. In the case of the most massive stars, the core collapse can produce a black hole, an object so dense that within a certain radius not even light can escape its gravity. Black holes themselves emit no light, but we infer their presence by their effects on surroundings, X-rays from hot gas, in accretion disks swirling into them, gravitational waves when they merge, or stars orbiting an invisible mass. In fact, at the very centre of our Milky Way galaxy, far deeper inward than our travels have yet taken us, lies a supermassive black hole, millions of times the Sun's mass. We cannot see it directly, though an image of its shadow was famously captured recently by radio telescopes. But we see stars whipping around an unseen object, moving at speeds of thousands of kilometres per second. This heavy, dark heart of the galaxy quietly affects the orbits of stars near it, and occasionally devours any straying gas or star that comes too close. Yet from our vantage point, 26,000 light years away, the black hole is essentially benign, just another component of the galaxy's ecosystem. We have now travelled far enough to step back and gaze at our entire Milky Way. Our Sun is one of perhaps 300 billion stars in this spiral galaxy. If we could rise above the galaxy, we'd see a flat disk about 100,000 light years across, with a bright central bulge. Graceful spiral arms emanate from the core, winding outward like a giant pinwheel. Our solar system is located in a modest spur of one of these arms, the Orion arm or local spur, roughly 27,000 light years from the centre. The Milky Way's spiral arms are sites of active star formation. They appear bright with young stars and nebulae, like cosmic traffic jams, where gas clouds compress to form stars. Between the arms, older stars orbit quietly. Surrounding the luminous disk is a faint halo of old stars and globular clusters, spherical clusters containing hundreds of thousands of very ancient stars. We encountered one earlier conceptually. These globular clusters, like the Great Cluster in Hercules or Omega Centauri, are tight balls of stars orbiting the galaxy's centre in the halo. They are among the oldest formations in the galaxy, around 10 to 12 billion years old, relics of the early Milky Way. Within the disk, as we journey from the outskirts inwards, star density increases. The night sky on Earth, in a rural dark area, shows the Milky Way band prominently in the direction of Sagittarius. That's because we are looking towards the galaxy's centre, where stars are densely packed and interstellar dust clouds abound. If one were near the galactic centre, the night sky would be ablaze with countless stars far brighter than any seen from Earth. But also interstellar dust would block the view in many directions. The very core of the Milky Way, hidden behind dust clouds, harbours that supermassive black hole called Sagittarius, a star. Around it, stars orbit in tightly curved paths. Some have been observed completing an orbit in just a decade or two. The energy and star density is intense there, a place very unlike the neighbourhood of our comparatively tranquil sun. Our galaxy is just one among countless. Indeed, as we drift out beyond the Milky Way, something our imagination must do, since physically this is far beyond reach. We can turn around and look at it from outside. Perhaps it would resemble the beautiful spiral of the Andromeda Galaxy or the Whirlpool Galaxy, a brilliant disk with swirling arms. The Milky Way likely has two major spiral arms and several lesser arms or segments, and a thick bar of stars across the centre. Our imaginary vantage point makes the groupings of stars and nebulae in the arms apparent, and the majestic structure emerges from the darkness. It is a truly magnificent island of light in the cosmos. But the Milky Way is not alone in space. It has companions, a small entourage of satellite galaxies, and at least one true companion galaxy of similar size. Our nearest large galactic neighbour is the Andromeda Galaxy M31, about 2.5 million light years away. From Earth, Andromeda is visible as a faint smudge in a dark sky, similar to how the Milky Way might appear from elsewhere. It is a spiral galaxy, somewhat larger than the Milky Way, with possibly 1 trillion stars. Together, Andromeda, the Milky Way, and dozens of dwarf galaxies, such as the Magellanic Clouds, visible from the southern hemisphere, and others like Leothorn, Sextans, Draco, etc., form the local group, a small, gravitationally bound cluster of galaxies, about 10 million light years across. We move now as disembodied observers, crossing the intergalactic gulf to visit Andromeda. As we approach it, the spiral shape becomes discernible, a bright central bulge and graceful, if somewhat dusty, spiral arms. We see clusters of hot blue stars marking its arms and dark lanes of dust, similar to those in the Milky Way. Perhaps we take a moment to imagine what the night sky might look like from a planet in the Andromeda Galaxy. If that planet's star is near Andromeda's outskirts and faces the Milky Way might appear as a small, faint spiral in their sky, just as Andromeda does in ours. In a poetic twist, someone in Andromeda could be wondering about that tiny Milky Way galaxy visible in their telescopes, much as we wonder about Andromeda. The Milky Way and Andromeda are on a collision course. In about 4 billion years, these two giant spirals will draw close and begin to merge. We envision a time lapse of this epic encounter. First, Andromeda, in Earth's night sky, will grow larger over millions of years until its spiral arms are visible to the naked eye. Then long after any humans are likely around, the galaxies will begin to distort each other with tidal forces. When they collide, it's not like a car crash. Galaxies are mostly empty space. The stars will largely pass by one another without direct collisions, but gravity will scramble the orbits of stars. Some will be thrown out into intergalactic space. Others will migrate to new positions. The gas clouds in each galaxy, however, will collide and compress, likely igniting a tremendous burst of new star formation, a firework of starbirth, lighting up both galaxies. Over a few billion years, the two spirals, now an entwined wreck of tidal tails and overlapping disks, will eventually settle into a single, larger galaxy, probably an elliptical galaxy with a hazy, rounded shape. Our sun, if it still exists then, and hasn't been thrown out or turned into a white dwarf, will find itself in a very unfamiliar cosmic city. Andromeda's and the Milky Way's central black holes will likely merge as well, forming an even more massive central black hole. For now, in our epoch, Andromeda stands as a majestic twin island universe nearby. A galaxy with perhaps its own civilizations and stories, although we have no evidence of them. It reminds us that our galaxy is not the whole universe, but one member of a community. Indeed, the universe is dotted with uncountable galaxies. Some are solitary, drifting quietly. Others are gathered in enormous clusters containing hundreds or thousands of galaxies bound by their mutual gravity. Our local group is drifting toward the larger Virgo cluster, a massive cluster of galaxies about 50 million light years away that contains over 1,000 galaxies. If we teleport to the centre of the Virgo cluster, the view would be extraordinary. Many galaxies of various shapes, crowding the sky, far brighter than Andromeda appears to us, filling the blackness with faint, fuzzy patches of light of all sizes. In that environment, intergalactic space is not quite so empty. The cluster is bathed in a faint glow of stray stars torn from galaxies by interactions. An X-ray emitting hot gas permeates the cluster's volume. As we continue to zoom out, we see that galaxies often form filaments and sheets, with great voids in between, the cosmic web of large-scale structure. Our local group and the Virgo cluster are part of the Laniakea supercluster, a giant association of clusters and groups spanning hundreds of millions of light years. Superclusters themselves seem to merge into long filaments or walls of galaxies, like the Great Wall, Sloan, Great Wall, etc., surrounding voids that can be tens of millions of light years across with very few galaxies inside. The deeper we peer into space, the further back in time we look. Light takes time to travel, so a galaxy 1 billion light years away is seen as it was 1 billion years ago. With powerful telescopes like Hubble or the new James Webb Space Telescope, we have stared across vast reaches of space and time. The famous Hubble Deep Field was one such effort, pointing the Hubble at an empty patch of sky for days to collect any trickle of light. The result was astonishing. Not darkness, but a patch of sky, seemingly tiny. About the area, a grain of sand covers at arm's length, filled with thousands of galaxies of all shapes, colours and sizes. Nearly every smudge in that image is an entire galaxy. Some as they were over 12 billion years ago, when they were young. We see galaxies in those deep fields that are smaller and more irregular than large modern spirals. We catch them in the act of growing and merging. We see collisions and starbursts and the faint glow of red-shifted light from some of the first galaxies that formed. Our understanding is that roughly 13.8 billion years ago, the universe as we know it began in what we call the Big Bang, a hot, dense state that expanded and cooled. In the first moments, space itself inflated rapidly. As the universe expanded, it cooled enough for particles to form, and atoms, and after about 380,000 years, the blinding glow of the hot plasma decoupled from matter, leaving behind a pervasive afterglow. The cosmic microwave background radiation, CMB. This CMB is now stretched to microwaves by the expansion of the universe and comes to us from all directions, an almost uniform whisper of that primordial light. For ages after the Big Bang, there were no stars, The universe was a dark place, filled with cooling hydrogen and helium gas. Then gravity began gathering this gas into the first stars and galaxies. The first stars were likely very massive, hot and short-lived, ending in supernova explosions that seeded space with the first heavy elements. Galaxies began as small clumps, merging over time to build the larger galaxies we see today. We live in a universe that is dynamic and evolving. If the entire 13.8 billion year history of the universe were compressed into one calendar year for perspective, the Big Bang would be at the start of January 1st. The Milky Way might form around May. Our solar system appears around early September. Life on Earth arises by late September. Complex life, multicellular life, emerges in mid-December. Dinosaurs roam on December 26th and die out on December 30th. Modern humans, Homo sapiens, appear at around 11:52 p.m. on December 31st, just 8 minutes before midnight. All of recorded human history is in the last 60 seconds before midnight of that cosmic year. This puts in perspective how ancient the cosmos is compared to our brief existence. Knowing our place in time and space can indeed be humbling. The universe is so vast and old, and we're so small and new. But it is also deeply inspiring. We, who started as star stuff and achieved consciousness, can observe and understand some of this grand universe. The cosmos is within us. We are a way for the universe to know itself, one astronomer remarked, encapsulating the idea that through our eyes, the universe, in a sense, gazes upon itself with wonder. We feel small under the stars, but simultaneously we feel enriched, made of that same star matter, connected through time and space to the entire cosmos. This cosmic perspective can also bring comfort. Under the vast sky, the petty boundaries between nations and the trivial troubles of daily life fade away. We are all sailing together on a tiny planet through an immense universe. The starlight that falls equally on everyone reminds us that we share a common origin and destiny. Every atom in our bodies was born in stars. Every breath we take and every element that sustains us has a cosmic pedigree. In that knowledge lies a profound sense of kinship with each other and with the cosmos itself. We are children of the universe, united by the stardust in our veins and the light that shines on us. As we search the night for meaning, we also naturally wonder about companionship out there. With billions of stars in our galaxy, many of them hosting planets, as modern science has increasingly shown, it seems unlikely that Earth is the only world where life took hold. In recent decades, astronomers have confirmed over 5,000 exoplanets, planets orbiting other stars, and statistical studies imply there may be hundreds of billions of planets in the Milky Way. Many of these planets reside in their star's habitable zone, where temperatures could allow liquid water. They come in an astonishing variety. Some giant gas worlds hugging close to their stars, some ice-cold loners far out, some possibly rocky Earth-like ones in between. We know of planets with two suns like the fictional Tatooine. In reality, Kepler 16b was found to orbit a binary star. We found planets where 1 year lasts only a few days and others that take centuries to circle their sun. We can hardly constrain our curiosity. Could any of those myriad worlds harbour life? Microbial life, perhaps, or even intelligent civilizations looking back at us. Yet despite our search, listening with radio telescopes for signals, scanning with telescopes for any techno-signatures, we have not yet heard the whisper of another civilization. The universe, as far as we can tell, remains quietly mum on that score. Some say we haven't listened long enough. After all, a century of radio is nothing on cosmic timescales. Some wonder if advanced civilizations are very rare or short-lived, or too far apart in space and time to meet. But the silence itself has its own intrigue. It keeps us searching, straining to detect a faint hello in the cosmic static. And if one day we do detect an alien signal or find undeniable evidence of life on an exoplanet, how profoundly it will change our view of the cosmos and ourselves. Even if intelligent life is sparse, life in simpler forms might be common. Perhaps in our own solar system, microbial life persists in subsurface oceans of moons like Europa or Enceladus, or in the soils of Mars. We haven't found it yet, but we continue to explore. The ingredients for life, water, organic molecules, energy sources, seem to abound. We've discovered organic chemicals in interstellar clouds, amino acids in meteorites, and whole ecosystems on Earth, thriving in extreme conditions, once thought uninhabitable, like around deep-sea vents or inside rocks, miles underground. Life, it appears, finds a way, if given half a chance. So one cannot help but feel that the cosmos might be teeming with living things, even if much of it is microbial or primitive. And somewhere, perhaps rarely, the spark of intelligence might catch and civilization ignite as it did on Earth. For now, as far as we know, we are the only such spark. And that realization lends a sense of preciousness to our existence. We have peered across billions of light years and back billions of years in time. We've discovered the laws that govern stars and galaxies. We've sent our clever machines to neighbouring worlds and even beyond the solar system. Yet our continued survival and flourishing are tied to a pale blue dot we call home. The quest to explore and understand the universe ultimately teaches us also to cherish our planet and each other. Because in the grand emptiness, Earth is a rare garden of life. Looking ahead, we can dream of futures where humanity, or our descendants, does not remain confined to Earth. The same restlessness and curiosity that sent sailors across uncharted oceans might one day send us to settle the Moon, Mars, and other worlds. Imagine, in the not too distant future, domed colonies on the Moon, where the Earth looms in the black sky, a blue marble that never sets on the lunar horizon. Or picture greenhouses and habitats on Mars transforming pockets of the red planet into livable hamlets. Children might grow up under an alien sky playing in low gravity, the distant sun slightly smaller than we know, and Earth a bright star, twinkling in the dusk. Perhaps we'll build rotating space habitats, enormous cylindrical stations with Earth-like environments inside, complete with forests, rivers, and small towns, all spinning to create gravity. These could orbit Earth or the Sun, becoming new homes for humanity, like O'Neill colonies, straight out of science fiction, made real. In such a cylinder, night and day would be managed by mirrors, and if you looked up, you might see, across the curved interior, another ground above, with people walking upside down relative to you, really just on the other side of the habitat. Venturing further out, maybe in a century or two, we might launch interstellar probes, or even generation ships, self-contained worldlets, carrying pioneers in suspended animation, or multi-generational crews. to nearby star systems. The journey would be long, but with no urgency if we take it step by step. One can imagine a scene far in the future, a starship arriving here at an Earth-like planet, orbiting another star, human explorers waking up to see a new sun in the sky ready to step onto a virgin world, with blue oceans and green continents, or perhaps a barren rock that they will terraform over centuries. If we become wise stewards of our knowledge and technology, we could spread the gift of Earth life to other sterile worlds, making them bloom. Barren moons could host gardens under domes. Parched planets could be given seas. Though these projects are monumental, they are not outside the realm of possibility over millennia. In doing so, we would also ensure the survival of life, including ourselves, against catastrophes that could befall one single planet. It's a beautiful vision. Life expanding beyond the cradle, taking root among the stars. Perhaps our distant descendants will look up at a sky with multiple moons, or even multiple suns, and feel at home beneath strange constellations, all the while remembering their origin on a faraway Earth. Imagine a time, millennia from now, when humans, or whatever we evolve into, have spread through a good portion of the Milky Way. They might regard the entire galaxy with the familiarity that we regard our hometown. By then, they might harness energies on colossal scales. They could build megastructures like Dyson spheres, huge swarms of satellites, absorbing a star's output, effectively capturing most of the star's energy for their use. If such a thing were built around a star, to distant observers the star might slowly dim or disappear from visible light, detectable only in the infrared from the waste heat. Perhaps even now, in some far-flung galaxy, advanced beings have constructed such megastructures, and some stars that astronomers have catalogued as mysteriously dimming might indeed be enveloped by mega-engineering. The thought that technology and life could become cosmic in scale is at once mind-boggling and thrilling. Beyond even that, one can imagine civilizations so advanced they manipulate the fabric of space-time, or migrate entirely into digital or quantum realms, or harness the power of black holes or vacuum energy. These ideas teeter on the edge of science fiction, and we, in our current state, can only speculate dimly. The universe is about 13.8 billion years old. Our solar system is only 4.5 billion years old. There could be civilizations out there around older stars that have existed for millions or even billions of years longer than us. If they survived and continuously advanced, their capabilities would be beyond our comprehension. Perhaps they long ago spread to many galaxies, or transcended physical form, or perhaps intelligence is so rare that we truly might be among the first. We do not know. As our minds expand to these possibilities, we touch the edges of philosophical thought as much as scientific. And then there lies the tantalizing concept of the multiverse. Modern physics theories like eternal inflation, or string theory's landscape, or the many worlds interpretation of quantum mechanics, have opened the door to the idea that our universe might not be the only universe. There could be countless others, maybe an infinite ensemble of parallel universes, each with different initial conditions, or even different physical laws. These other universes might be forever separate from ours, unreachable and undetectable, except perhaps by subtle fingerprints in cosmological data or not at all. It's speculative, yes, but intriguing. If true, everything we know, all the trillions of galaxies in our visible universe, all the stars and wonders we've described, could be just a small part of an even vaster multiverse reality. In some of those universes, conditions might be such that no stars form, just thin hydrogen soup. In others, physics might allow entirely different kinds of particles, forces, and structures beyond our imagination. The multiverse idea, if contemplated too directly, can be overwhelming. It suggests an infinity of realities, some perhaps somewhat like ours, some wildly different. Philosophically, one can question what that means for meaning and purpose, but perhaps that is beyond our night's gentle contemplation. What it certainly does is stretch the boundaries of wonder. Creation, it seems, may be boundless. Our universe is already so vast, yet there might be an infinity of universes beyond it. Thinking about such enormities can indeed make one feel adrift and insignificant. But here, under the stars, that feeling is tempered by something comforting. We are part of this, and it is part of us. We've travelled mentally, across billions of light years, but now we ease back to the present moment, lying under the vault of the sky. The cosmos above is still and silent. The constellations, we know, wheel slowly with the Earth's rotation, exactly as they have done for countless nights before, and will for countless nights after. The familiar stars are like old friends in the darkness, unchanged by our flights of fancy. The steady cycle of night and day on Earth continues, a dependable rhythm in the midst of cosmic change. Allow yourself to bask in that starlight and the enormity of what it represents. Feel the solid ground beneath you. Realize that even as we journeyed far in our minds, you remain safely here, a child of Earth and the cosmos at once. The atoms in your body resonated with the tale of the stars because it is their own story too. In a very literal sense, the universe is not out there, separate from you. It is within you. You are a microcosm of the cosmos. We are the universe, shaped into thought and dreaming about itself. We belong here, utterly and completely. Now the night has deepened. If the moon is up, its gentle light washes the land in silver, and if it has set, the pure starlight reigns. You might catch a final shooting star flitting across the sky, a last gift from a long-gone comet, drawing your wish as it fades. The cool night air settles. A sense of tranquility grows. Relax into this feeling of cosmic unity and peace. The universe is vast beyond imagining, and full of wonders beyond counting. Yet it is also a place of profound calm and order. Stars are born, stars die, galaxies collide. But on human timescales, these changes are imperceptibly slow, and the night sky seems almost eternal. That constancy can be a great comfort. No matter what happened today, or what will tomorrow, the stars will wheel in their courses tonight. The Milky Way will glow softly, and dawn will eventually arrive right on schedule. There is something deeply reassuring about that. So far we have journeyed across cosmic shores, guided by starlight and curiosity. In the meditative glow of the universe, our exploration revealed wonders from shimmering nebulae to swirling galaxies. Now, we continue our voyage deeper into the cosmos, drifting further into the depths of time and space. Above us, the celestial canopy stretches to infinity, whispering secrets of creation and destiny. The universe unfolds like a grand tapestry before our inner eye. Each star is a story, each galaxy a chapter in this cosmic epic. With calm hearts and open minds, we venture onward, moving beyond the familiar marvels into profound mysteries. The evolution of cosmic structures, the life and death of stars, the fate of galaxies, and the silent forces that steer the cosmos. Science and imagination blend as we gently explore, inviting wonder without haste. Imagine yourself drifting among the stars, afloat in the quiet sea of night. The Milky Way arches overhead like a bridge of misty light, each of its countless stars, a distant sun with its own tale. Feel the timelessness of this moment. We are about to explore cosmic evolutions that span billions upon billions of years, intervals so vast our human minds can barely grasp them. Yet we will try, unfolding the story piece by piece, guided by the slow rhythm of a universe far older and larger than any single life. How did the grand design of the cosmos emerge from simplicity? Let us begin where structure first took shape. In the stillness, we turn our gaze back to the early universe, to watch the evolution of cosmic structures quietly begin. In the beginning, the universe was a formless expanse of energy and light. In that newborn cosmos, everything was hot, dense, and nearly uniform. There were no galaxies, no stars, only a glowing haze, slowly expanding and cooling. Yet even in this primordial simplicity, there were tiny imperfections, like faint ripples on a glassy sea. These ripples were slight variations in density, seeds of structure planted in the fertile ground of space-time. As eons passed and the universe grew larger and cooler, gravity began its gentle work. Wherever matter was a bit denser, its gravity drew in more matter, and those regions grew denser still. Quietly, invisibly, the first patterns emerged. Vast clouds of hydrogen gas, the simplest element, born of the Big Bang, gathered and swirled. Under gravity's patient pull, the gas condensed into clumps. These were the cradles of the first stars and galaxies, though no eye yet existed to see them. In that ancient darkness, perhaps a few 100 million years after the universe's birth, light began to appear. The dense clumps of gas ignited as the very first stars were born. They were unlike the stars we know today, immense, extremely hot, and short-lived, for they burned their fuel quickly. Scattered across the cosmic ocean, these newborn stars formed the first star clusters and protogalaxies. Each cluster became a tiny island of light in a vast sea of night. The early galaxies were small and ragged compared to the grand spirals and ellipticals we see later in cosmic history. They danced around each other, drawn together by gravity. When two protogalaxies drifted too close, they merged, joining their stars and gas to become a larger galaxy. Over billions of years, countless mergers built up the majestic galaxies we know, spirals with graceful, curving arms and ellipticals, like giant, diffuse clouds of stars. Through this cosmic dance of union and accretion, structure blossomed from initial chaos. Zooming out, we see that galaxies themselves did not form in isolation. They collected into groups and clusters, bound by mutual gravity. Our own Milky Way is part of a small cluster of galaxies called the local group. Beyond that, larger clusters contain hundreds or thousands of galaxies bound in colossal swarms. Even those clusters themselves gather into superclusters, forming threads and filaments across space. It is as if the universe wove a vast cosmic web. Imagine a web stretching in all directions, its threads defined by chains of galaxies glimmering like dew on a spider's web in the morning light. Where the threads intersect, great clusters of galaxies shine as cosmic nodes. Between these filaments lie enormous voids, immense expanses of nearly empty space, where only the occasional galaxy lights the darkness. This is the large-scale structure of the cosmos, a tapestry of matter and light on the grandest scale we can conceive. There is mystery in this architecture. Much of the scaffolding of the cosmic web is invisible. An unknown kind of mass, dark matter, quiet and transparent, outweighs the visible stars and gas. It does not shine or interact with light except through gravity, yet it shaped the formation of galaxies, providing an unseen framework for ordinary matter to clump. In the silent early cosmos, this dark matter gathered first, drawing in gas that would later blaze as stars. We cannot see this dark matter directly, but its presence is felt in the way galaxies spin and cluster, a ghostly guide in the growth of structure. Over time, the cosmic web became ever more pronounced. By a few billion years into cosmic history, galaxies had formed a vast foam-like pattern across the universe. If we could watch a time-lapse of it all, we would see filaments of galaxies growing like branching rivers, clusters becoming denser as gravity draws more matter in, and voids widening as matter flows into the denser regions. The universe transformed from a near uniform glow to a frothy expanse speckled with galaxies, a transformation from simplicity to complexity on a scale beyond imagination. Yet even as this grand design took shape, it continued to evolve. Galaxies were not static. They were living, changing systems. Within them, new stars formed while old stars died, constantly altering each galaxy's appearance. Galaxies collided and merged, sometimes tearing spiral arms askew, or igniting flurries of new star birth. Through all this, the underlying cosmic web endured, though it slowly grew more diffuse as the universe expanded further from a featureless blaze of creation. The cosmos grew into a rich kingdom of structure. Stars gathered into galaxies, galaxies into clusters, clusters into a web that spans billions of light years. The scale is almost impossible to fathom. Each galaxy may hold billions of stars, and there are billions of galaxies across the observable universe. In the stillness of a single human lifetime, these structures seem unchanging and eternal. But on cosmic timescales, they are dynamic and ever developing. We have traced how the cosmic tapestry was woven, from faint primordial ripples to the grand filaments of galaxies. It is a story of gravity's slow artistry, patiently crafting order from initial uniformity. Now our journey brings us closer, shifting focus from the grand cosmic web to the individual actors within it, the stars themselves. Each star is born, lives and dies, illuminating its corner of the cosmos before passing the torch to a new generation. In a cold, diffuse cloud at the edge of a galaxy, a delicate drama unfolds. The cloud is immense and dark, composed of gas and dust, silent and frigid, waiting for a spark. Over millions of years, a gentle disturbance, perhaps the shock wave from a distant supernova or the merging of two clouds, triggers the collapse of part of this nebula. Slowly, pockets of gas draw together under gravity's embrace. What was once a shapeless expanse begins to coalesce into denser clumps. In the heart of one such clump, pressure and temperature climb quietly. At first it's just a protostar, hidden within a cocoon of dust, warming up but not yet shining. We drift closer to witness the moment when the protostar's core becomes hot and dense enough for a miracle. Nuclear fusion ignites. With that first spark of fusion, a star is born. Light that had been absent for eons now radiates outward, pushing away the surrounding shroud of gas and dust. The newborn star emerges from its nebula, like a pearl revealed, glowing softly. At this stage it may be a T-Tauri star, youthful and variable, still gathering mass. Eventually, it settles into a stable life, shining steadily. The once dark cloud has given birth to a brilliant beacon. Scattered across our galaxy, countless such stellar nurseries are at work, each speckled with infant stars wrapped in luminous nebulae. One famous example is the Orion Nebula, a vast cradle of stars that glows with the combined light of thousands of young suns. Though we observe from afar, imagine being within it, a sky filled with hazy light, new stars like lanterns emerging from mist. It is a cosmic nursery, serene yet bustling with the creation of suns. As stars are born, they are often not alone. Siblings form in the same cloud, making clusters of young stars that drift together through the galaxy. Some stars will have companions orbiting each other in binary systems, a twinned destiny from birth. Around many new stars, a rotating disk of leftover gas and dust circles, the residue of creation. Within those disks, dust grains gently collide and stick, gradually building up into planets and moons. Thus, a star's birth often heralds the birth of an entire solar system, a family of worlds to accompany the star on its journey through time. Once settled into their mature life, stars shine with amazing consistency. In this long middle age, a star fuses hydrogen into helium in its core, releasing energy that balances the inward pull of gravity. Our own sun is in this peaceful stage, gracefully converting millions of tons of hydrogen each second to light and heat, yet changing so little that billions of years pass with only subtle changes. Stars can live in this state for vastly different lengths of time, depending on their mass. A small, cool red dwarf star sips its fuel slowly and burns for trillions of years, far longer than the universe has existed so far. A massive blue-white star, on the other hand, devours its fuel quickly in a flamboyant life that might last only a few million years, a mere blink on cosmic scales. Consider a mighty star, perhaps 20 times the mass of our sun. It blazes fiercely, its surface hot and blue, pouring out light and strong stellar winds. For a few million years, it dominates its region of space, its brilliance outshining lesser stars. Yet this extravagant brightness comes at a cost. The star's fuel in the core is exhausted rapidly. In contrast, picture a tiny red dwarf, maybe a tenth the sun's mass. It emits only a faint, reddish glow, perhaps too dim to see without a telescope from afar. But this little star is thrifty. It will shine on for hundreds of billions, even trillions of years, long after larger stars have lived and died. Most stars, including those like our sun, eventually exhaust the hydrogen at their core. When that moment arrives, the delicate balance keeping the star stable is upset. The core, now filled with helium ash from eons of fusion, begins to contract under gravity as fusion slows. This contraction raises the core's temperature and pressure until helium itself ignites in fusion. Meanwhile, the outer layers of the star respond to the core's contraction by expanding outward. The star swells into a red giant. For a star like the Sun, this is a graceful but enormous transformation. Its outer layers push outward into space, cooling and reddening, engulfing any nearby planets. In the far future, our Sun will become such a red giant, likely swallowing Mercury and Venus and casting a rosy glow over any surviving worlds. In this red giant phase, the star's appearance changes drastically. Once a steady yellow star, it becomes a vast luminous ember, hundreds of times larger in diameter, though cooler at the surface. It pulsates gently, its outer layers loosely bound by gravity. Eventually, those outer layers drift away entirely, pushed by stellar winds and slow pulsations, forming an expanding shell of gas around the dying star. The core, meanwhile, has fused helium into carbon and oxygen. For a Sun-like star, fusion cannot continue much beyond that point. The core is not massive enough to ignite carbon, thus the end of the line is reached for fusion. The hot core is left behind, exposed, a brilliant point no larger than Earth but incredibly dense. This is a white dwarf, the final state of stars like our Sun. It shines from residual heat, slowly cooling over billions of years. Surrounding it, the cast-off outer layers form a glowing planetary nebula. This term comes from early astronomers who thought these shells looked round like planets through small telescopes. These nebulae come in beautiful shapes, rings, hourglasses, butterflies, as the dying star's last breath spreads into space. Over tens of thousands of years, the nebula will disperse into the interstellar medium, leaving the white dwarf to cool alone. What about the more massive stars, those cosmic titans that burned blue and bright? Their fate is even more dramatic. When a massive star exhausts its core hydrogen, it too expands into a supergiant, often a red or blue supergiant depending on its mass and composition. These stars can fuse heavier and heavier elements in a layered, onion-like structure in their core. Hydrogen to helium in the outer shell, helium to carbon in a deeper shell, then oxygen, and so on, each stage shorter than the last. But this progression cannot go on forever. Iron is the last element that fusion produces without yielding energy. When a massive core becomes mostly iron, the star faces an existential crisis. Fusion in the core ceases because fusing iron consumes energy instead of releasing it. Without the outward pressure from fusion to support it, the massive core succumbs to gravity and collapses under its own weight in an instant. The collapse happens unimaginably fast. In less than a second, the core of a giant star, many times the mass of the Sun, implodes. Protons and electrons in the core are crushed together into neutrons. The core, which might have been the size of Earth, shrinks to a sphere only a few kilometers across. This tiny core is incredibly dense as an atomic nucleus, and it resists further collapse fiercely. The inrushing material slams into the stiff neutron core and rebounds, creating a colossal shockwave. The star then does something truly extraordinary. It explodes. This explosion is a supernova, one of the most energetic events in the universe. For a brief time, the dying star can outshine its entire galaxy, unleashing the energy of billions of suns in a titanic blast. The outer layers are hurled into space at thousands of kilometers per second, enriched with all the heavy elements that were forged in the star's final moments. After a supernova, what remains of the star? The core, if it was not too massive, survives as a neutron star, an ultra-dense, fast-spinning sphere of neutrons. Neutron stars are like giant atomic nuclei packing the mass of 1.5 suns into a city-sized sphere. They often spin rapidly, and if their magnetic fields are strong, they can emit beams of radiation as they spin. These are pulsars, lighthouses of the cosmic sea, blinking on and off as their beams sweep past Earth. A pulsar's regular beats are like the ticking of a cosmic clock, a reminder of a star's powerful afterlife. Sometimes a neutron star can be born with such intensity that it vibrates space-time itself, sending ripples known as gravitational waves faintly across the cosmos. These were predicted by theory and have been observed in modern times when neutron stars or black holes collide. In our context, imagine a lone, newborn neutron star still ringing like a bell from the supernova's force, sending gentle tremors through the fabric of the universe. If the original star was extremely massive, perhaps more than 20 or 30 times the Sun, then even the neutron star state cannot hold it up. The core collapses further, and no known force in the universe can stop it. The stellar remnant becomes a black hole, an object so dense that within a certain distance, the event horizon, not even light can escape its gravity. This newborn black hole is often shrouded by the wreckage of the supernova explosion, which eventually expands and thins out into a supernova remnant, a ghostly nebula marking the site of the star's demise. Over thousands of years, that nebula too disperses, mixing its rich brew of heavy elements into the surrounding space. In this way, a star's life ends in either a quiet fade for smaller stars or a spectacular detonation for massive ones. In both cases, the star's material is returned to the galaxy, where it can become part of new stars, new planets, new life. The carbon in our bodies, the calcium in our bones, the iron in our blood, those atoms were forged in the hearts of stars or in the cataclysm of supernovae. Long before our sun existed, some ancient star lived and died, scattering those elements into the cosmos, where they coalesced in a nebula that eventually formed our solar system. In this way, each generation of stars passes a legacy to the next. The galaxy is like a forest, where old stars, giant trees fall and decay, nourishing the soil for new saplings to grow. Sometimes this cycle produces visible tributes in the sky, such as the Crab Nebula, the remnant of a supernova observed by humans in 1054 AD, now a beautiful cloud of glowing gas expanding outward, with a pulsing neutron star at its centre. Or the Ring Nebula, the shell of a long-dead sun-like star, appearing as a delicate smoke ring in the darkness. These cosmic remnants remind us that even in endings, there's creation and beauty across the universe in countless galaxies. The stellar life cycle is ongoing. Stars are born in luminous nebulae. They shine for ages in various hues and brightnesses, and they fade or explode, seeding space with the materials for new stars. It is a great cosmic recycling, ensuring that matter is used again and again to create new wonders. The night sky twinkles with stars of different ages. Young blue stars clustering in spiral arms. Middle-aged yellow suns like ours, scattered in galactic disks. And ancient red stars congregating in globular clusters, or galactic halos. They represent a continuum of life stages, a cosmic family of generations. As we gaze upon a starry night, nearly every pinpoint of light is a star at some point in its life. Some might be relatively newborn, others nearing their end. But from our distant vantage, they seem timeless and unchanging. Only through patient observation and understanding can we decipher their life stories written in their faint and ancient light. Knowing this, the sky becomes even more poetic. The red star Betelgeuse in Orion's shoulder is a bloated supergiant nearing the end of its life on an astronomical timescale, meaning it could explode into a supernova any time in the next few thousand to 100,000 years. A blink in cosmic time. The blue star Rigel, in Orion's foot, is younger and fiercely bright, living its short life at full intensity. Each star we see is on its own journey, from birth to death. A journey both humbling and inspiring to contemplate. Our exploration of stars' life cycles shows the incredible resilience and interconnectedness of the cosmos. From the faintest red dwarf, quietly glowing for trillions of years, to the most massive supergiant ending in a brilliant supernova, every star contributes to the cosmic story. And remarkably, through their deaths, stars sow the seeds of new stars and planets. It is an endless cycle of renewal on a cosmic scale, a symphony where each star's life is a note in a grand composition. Now we drift from individual stars to a grander stage. Stars seldom exist in isolation. They gather in immense communities known as galaxies. Just as stars have their life stories, so too do galaxies evolve over time. These vast assemblies of stars are not eternal and unchanging. They are shaped by time, environment, and sometimes dramatic encounters with one another. Gently, our perspective widens to examine the life cycle of galaxies, the rise and transformation of these magnificent cosmic cities of stars. Galaxies are the vast cities of stars that populate the universe, each a glimmering island in the cosmic ocean. Just as stars are born and change, so too do galaxies grow and evolve. In the early epochs of the universe, we saw how small proto-galaxies merged to form larger ones. Now let us observe a galaxy's life in more detail, from its youthful shine to its mature grace and beyond. In their youth, galaxies are often irregular and busy, full of gas and dust, actively forming stars at a brisk pace. Picture a young galaxy not long after its formation. Gas clouds within it collapse into numerous new stars lighting up the galaxy with brilliant blue starlight. The rate of star birth is high, and massive stars live fast and die in supernova, enriching the galaxy's gas with heavy elements. This is a turbulent time. Supernova shockwaves stir the gas, and energetic winds from young stars and exploding stars can even blow gas out of the galaxy. Many young galaxies also experience quasar phases. At their centres lurk supermassive black holes, and when large amounts of gas funnel into these central black holes, they ignite as quasars. A quasar is an intensely luminous beacon, powered by hot gas spiralling into a black hole's grasp, shining brighter than the entire galaxy around it. During these active times, the core of the galaxy may outshine all its stars combined, sending out torrents of radiation. Quasars signal a kind of energetic adolescence for galaxies, seen more frequently in the distant past of the universe. As time flows on, a galaxy often settles into a more steady form. The once abundant gas begins to be used up or blown away. Star formation slows from its frenzied early rate. The galaxy's shape becomes more defined. Some take on the elegant spiral form, with curving arms sprinkled with new stars and a calm central bulge of older ones. These spirals display both youth and age in one majestic form. Others, often as a result of early mergers or life in a dense cluster, become elliptical galaxies, more rounded or egg-shaped, lacking distinct structure and composed mostly of older, redder stars. These ellipticals are like the old districts of a stellar city, their lights dimmer with few new stars to light up the night. Spiral galaxies, like our Milky Way, still have gas and dust in their spiral arms, giving birth to new stars here and there, albeit at a slower pace than in their youth. Galaxies do not live isolated lives. They interact with their neighbours. Gravity binds galaxies into groups and clusters, and inevitably, galaxies within these collections can draw near each other. When galaxies come close, they begin to dance a gravitational waltz. Over millions of years, the dance can lead to a merger, a slow-motion collision of entire galaxies. Imagine two spiral galaxies approaching one another. From a great distance, at first it seems like nothing unusual. But over time, their mutual gravity stretches each galaxy, drawing out long tidal tails of stars and gas. As they entwine, stars from one galaxy pass by stars of the other. Direct stellar collisions are extremely rare because of the vast distances between individual stars. However, the gravitational interactions dramatically perturb the orbits of stars and, importantly, compress giant gas clouds, often triggering a boom of star formation, a cosmic fireworks show of stellar birth, lighting up the merging galaxies. The two galaxies may loop around each other, colliding and merging after a few close passes. In the process, their original shapes are altered beyond recognition. The orderly spiral arms may be shredded and flung off into space, forming streams of stars. The remaining cores might coalesce into a jumbled shape. Eventually, what was two galaxies becomes one larger galaxy. Often, the result is an elliptical galaxy, because the chaos of the merger disrupts any disk structure and disperses much of the gas. The newly merged galaxy might have a burst of star formation initially, but then, having consumed or expelled much of its gas, it calms into a quieter existence with an aging population of stars. The central black holes of the two original galaxies likely merge as well, forming an even more massive black hole at the centre of the new galaxy. For a time, this central black hole might flare up, accreting leftover gas from the merger and shining as an active galactic nucleus before fading once the fuel is spent. Galactic mergers are transformative events, yet they are also a natural part of galaxy evolution. Large galaxies like our Milky Way have devoured many smaller ones over their lifetimes. Even now, the Milky Way is pulling in tiny satellite galaxies. Astronomers see streams of stars in our galaxy's halo, remnants of past devoured companions. In the distant future, a much larger interaction awaits us. The Milky Way and the Andromeda Galaxy, our nearest large neighbour, currently about 2.5 million light years away, are moving toward each other and are expected to collide roughly 4 billion years from now. When they meet, they will begin a slow, graceful gravitational dance. Over a couple billion more years, they will merge to form a single, much larger galaxy. Some predict it will be a giant elliptical, jokingly dubbed Milky. During this collision, our solar system might be carried to a new part of the merged galaxy, and great bursts of star formation may light up as gas clouds compress. From the perspective of any beings alive at that time, whether human descendants or other life forms, the night sky will change dramatically. Instead of the familiar bands of the Milky Way, they would see a sky dominated by a sprawling tapestry of stars and nebulae from the interacting galaxies, slowly morphing over eons into a new configuration. Galaxies continue to evolve long after their major mergers. Once a galaxy has few interactions left, perhaps it drifts in a sparse region of space, or it is already merged with most of its neighbours. It may enter a quiet senior phase. In these retired galaxies, star formation has all but petered out. The reservoir of gas needed to form new stars is largely gone, either used up in making previous generations of stars or blown away by energetic events. The galaxy's remaining stars grow old and die one by one. Without new stars to replace them, the overall light of the galaxy dims over the eons. Elliptical galaxies are often in this state, populated by long-lived red dwarf and red giant stars with hardly any young blue stars to add sparkle. They appear reddish or yellowish for this reason, a sign of an aging stellar populace. However, even in these quiet galaxies, the cycle of stellar birth and death might not be entirely over. Now and then, a trickle of fresh gas might fall in from intergalactic space or from a small satellite galaxy, potentially reigniting a bit of star formation. Or two retired galaxies might eventually collide and merge, perhaps creating a brief second spring of star birth if enough gas is present. But overall, as the universe ages, galaxies use up their gas. And the peak era of star formation lies in the past. It actually peaked around 10 billion years ago, when the universe was about 4 billion years old. The cosmos's stellar production is on a long, gradual decline. An interesting fate awaits galaxy clusters and groups as well. While gravity pulls member galaxies together, there is another process at work on larger scales: the expansion of the universe itself. Galaxies that are not gravitationally bound to us are receding, carried away as space stretches. In the very far future, only the merged remains of our local group, Milky Way Andromeda, and a few smaller galaxies might stay together. All other galaxies, including those now in our Virgo supercluster, will drift so far away that their light no longer reaches us. They will effectively vanish from view, not because they cease to exist, but because the immense expansion of space will carry them beyond our horizon of visibility. In that far epoch, any observers in our galaxy might see an empty sky beyond their own stars, a stark and lonely reminder that galaxies too can become isolated as cosmic expansion pushes others beyond reach. But we are leaping ahead of ourselves. That contemplation belongs to the universe's distant future. Returning to the present time, in our mind's eye, we see the universe as it is. A vast collection of galaxies of all types and ages. Spirals still turning gracefully, ellipticals glowing softly, irregular galaxies in odd shapes, testifying to past collisions, and more. These galaxies continue to move, interact, and change slowly. On human timescales, a galaxy's life is almost static. It takes millions of years for noticeable changes. But nothing in the cosmos is truly permanent. Galaxies, with their billions of stars, have lifespans measured in billions of years or more. They are long-lived compared to individual stars, just as a forest outlives the individual trees within it. And like forests, galaxies can regrow and change when conditions allow, or gradually wither when star formation ends. Observing galaxies at different distances is like looking back in time. We see them in different stages of their lives: energetic youth, productive maturity, and quieter old age. The young universe's galaxies look markedly different from modern ones, and we have managed to capture glimpses of these stages through our telescopes. Having seen how galaxies form, merge, and gradually wind down, we step back to look at a force that has been subtly influencing this story all along: the expansion of space. The universe as a whole has been stretching since the beginning. But late in cosmic history, a puzzling phenomenon began to dominate: the acceleration of this expansion due to something we call dark energy. To understand the ultimate fate of galaxies and the cosmos, we must explore dark energy and the universe's expansion, a force that shapes the destiny of all cosmic structures. For much of cosmic history, the universe's expansion was gradually slowing. Ever since the initial blast of the Big Bang, space itself has been stretching, carrying galaxies apart like raisins in rising dough. At first, the gravity of matter, galaxies, gas, dark matter, pulled against this expansion, trying to rein it in. One might imagine that given enough time or enough matter, perhaps the expansion would slow to a stop or even reverse into a collapse. That was one possibility many scientists considered decades ago. Another possibility was that expansion would continue forever, but slowly decelerating, with galaxies drifting farther and farther apart at a diminishing pace. However, the universe had a surprise in store. Billions of years after the Big Bang, something extraordinary began to dominate the cosmos. Observations of distant exploding stars, certain types of supernovae used as cosmic mileposts, in the late 20th century, revealed that the expansion of the universe is not slowing down at all. In fact, it's speeding up. The galaxies are receding from each other, faster and faster as time goes on. This was a shocking discovery. It was as if an unknown force was pushing the universe apart, overpowering gravity on the largest scales. We call this mysterious phenomenon dark energy. The name reflects our ignorance of its true nature. It's not dark in a visual sense, but rather invisible and not directly detectable, except through its effect on expansion. And we call it energy because it seems to be a property of space itself. Imagine that even empty space has a sort of latent energy, a pressure that causes it to expand. As space expands, more space emerges, and with it, more of this repulsive effect, leading to a self-perpetuating acceleration. It's as though the universe is imbued with a subtle breath that inflates the fabric of space steadily over time. Today, dark energy is thought to make up roughly 70% of the total content of the universe, with dark matter and ordinary matter comprising the rest. Yet we don't feel it in our daily lives or even within our galaxy, because its effect is incredibly gentle. On smaller scales, it's only noticeable when you accumulate vast reaches of nearly empty space, like the gulf between galaxy clusters. Over billions of light years, this faint pressure adds up to a formidable influence. Think of two distant galaxy clusters, separated by an immense stretch of space. Gravity between them tries to draw them together, but dark energy is like a tiny persistent push trying to drive them apart. If that push is small compared to the gravitational pull, as it was in the early universe, when matter was denser and closer together, gravity wins and structures like galaxies and clusters form. But as the universe expands, matter thins out, and gravity's grip weakens over cosmic distances. Eventually, the dark energy push dominates, and the expansion between those clusters and any not tightly bound begins to accelerate. We are living in an era where dark energy has recently become dominant. A few billion years ago, galaxies were closer, and the universe's expansion was slowing down due to gravity. Gradually, though, the balance tipped. Now, for the last 5 billion years or so, the expansion has been speeding up. In the far future, this acceleration will have dramatic consequences. Galaxies that are not already bound together by gravity will recede from each other at ever-increasing speeds. Many distant galaxies that we can see today will, one by one, slip beyond our cosmic horizon, the limit of the observable universe, meaning their light will no longer reach us. They will effectively disappear from our view, not because they cease to exist, but because space between us and them is expanding so fast that light cannot bridge the gap. Our journey through the cosmos has carried us across countless wonders, luminous ethereal nebulae, and swirling galaxies and distant worlds. Now, as we drift further into the quiet, star-washed reaches of space, a gentle cosmic silence surrounds us. The stars glimmer like distant lanterns, set in a deep velvet expanse, and the band of our Milky Way galaxy arches overhead like a faint glowing river, with no sound but the beating of our hearts and the whisper of our own thoughts. We feel truly afloat in the cosmic ocean. In this stillness, the vastness and mystery of the universe invites a deeper, more contemplative reflection. We find ourselves not just observers of the stars, but participants in a grand cosmic story, entwined with the very fabric of the night sky. Beneath an endless vault of stars, a sense of cosmic consciousness awakens. It's a subtle awareness that we, who gaze up at the galaxies, are made of the same luminous dust that twinkles above. The atoms that form us were born in ancient stars, and in our minds flickers the light of those long-vanished suns. We are more than small beings, lost in the void. We are the universe itself, perceiving its own immensity through human eyes. On a moonlit night, far from city lights, one can lie back on cool grass and feel the infinity overhead. The Milky Way spills across the sky, and in its silvery glow comes a whisper of connection. Each star above is a distant sun, and around some of those suns may circle planets with their own seas and skies. Perhaps on a faraway world, under an alien sky, another soul looks up and feels the same wonder. They might have 2 moons, or a sky tinted in unfamiliar colours, but the stars above spark a familiar question in their heart. In their own way, they wonder if someone else is out there, just as we wonder about them. For that distant observer, we are part of the mystery of the universe, just as they are for us. In that thought, the cosmos seems to grow smaller and more intimate, like a neighbourhood of houses under one shared sky. We do not yet know whether such distant neighbours truly exist. The universe is silent so far about other beings. If, in the vastness of space, we are the only ones who have awakened to awareness, then our role is singular and profound, to be the universe's lone, conscious voice, cherishing that gift of insight. If, on the other hand, the cosmos is teeming with life, then one day our awareness may meet another's, and the universe will know itself in a new, collective way. Either possibility fills the heart with wonder. In the meantime, the night sky keeps its quiet secrets, and we continue to send out our thoughts and probes as greetings in the dark. With each message and each listening ear turned skyward, we affirm hope that we are not alone. And even if we are, the cosmos we are a part of is rich enough in marvels to keep us company. This feeling of unity can arise in quiet moments. As you inhale under the night sky, the air filling your lungs carries atoms exhaled by trees and ancient forests, atoms that have drifted through clouds and across oceans to reach you. Those atoms have been part of countless forms of life before finding their way to you. In the same way, the starlight that falls gently on your face has travelled years or millennia to reach this moment. When it touches you, you become the meeting point of past and present, of distant stars and the earth beneath you. A calm sense of awe and reverence may dawn. You are an essential part of this vast unfolding cosmic tapestry. We often think of the universe as something outside and separate, a panorama we observe from a lonely shore. Yet consider that the boundary between out there and in here is delicate. The photons from a star enter your eyes and become tiny electrical signals in your brain. In that instant, a piece of a star has become part of your inner world of thoughts and feelings. The cosmos pours into us ceaselessly, through every sensation and every breath. In turn, we project our dreams and questions out into the cosmos, sending probes and prayers, radio signals and radiant hope. There's a continuous exchange, a conversation between the universe and our awareness, in the stillness of a clear night. Such thoughts flow naturally. One might recall lying by a crackling campfire, under a canopy of stars, feeling both incredibly small and profoundly connected. The stars seem to listen to the quiet of your mind. In that silence, you may sense that your own consciousness is like a mirror, reflecting the cosmos back to itself. After all, every idea we have about the stars comes from within the mind that evolved here on Earth, a tiny world orbiting a modest star in a galaxy among billions. And yet that tiny mind can envision the entire cosmos. It can ponder eternity and infinity, as though inside us we hold an echo of the boundless skies. Across time, humans have wondered if the universe itself could be conscious in some way. When we look out at galaxies swirling like giant storms of stars, some have imagined those might be the thoughts of a cosmic mind. This may be just poetic fancy, but it springs from a real sense of mystery and wonder. We find consciousness in ourselves to be the most immediate reality. We know we are aware, even if we do not fully understand how. And we see the organised complexity of the universe, from galactic clusters down to living cells, and we wonder, is it all mere coincidence? Or is there an underlying awareness threading through the cosmos? Science does not yet have an answer to the deepest questions of consciousness. But on a calm night, under the stars, one does not need an answer to feel a connection. It can feel as if the cosmos knows you, in the simple fact that it made you. The carbon in your muscles, the calcium in your bones, the iron in your blood, all were forged in the hearts of stars that lived and died billions of years ago. Those stars are gone, but a part of them now thinks and feels and looks up at the sky again. In that sense, the universe has recycled itself into living form capable of awe. Through our eyes, the universe gazes at its own ancient light. Through our ears, it listens to the cosmic silence and peace. In our hearts, it perhaps feels a little of its own immensity. Consider a single speck of iron in your blood, an atom riding within a red blood cell on its circuit through your veins. Where did it come from? Long ago, that iron atom was forged in a star's core, in a fantastically hot furnace. When that ancient star reached the end of its life, it exploded in a brilliant supernova, scattering its elements into space. The iron atom drifted through the galaxy as part of a gas cloud for millions or perhaps billions of years. Eventually, that cloud became part of a new star system, our solar system. In the young Earth, that atom mingled in rocks and soil. Through geological ages, it might have been washed into the ocean or drawn up into a plant and then eaten by an animal. Ultimately, it found its way into your body, perhaps in the food you ate or the water you drank. Now it travels inside you, helping to carry oxygen to your cells. In time, when your journey of life is complete, that iron will return to the earth, and maybe far future generations, or even new worlds, will carry it onward. This one tiny atom has crossed the cosmos and time to be part of you, a bridge between your life and the stars. Multiply that story by trillions. For every atom in you has a tale as astonishing. Realizing this, the line between you and the universe starts to blur, as indeed it should. This perspective can bring comfort and curiosity. If we are the universe aware of itself, then when we love, when we create art, when we explore, it is the cosmos expressing those very things. Every poem written about the stars, every equation scribbled to understand gravity, every lullaby sung to a child under the night sky, they are acts of the cosmos, understanding and cherishing itself. We often feel so separate and small, but in truth we carry the universe within us, not just in the physical sense of star stuff, but in the sense that our capacity for thought and emotion is as natural a part of the cosmos as the burning of a sun or the orbit of a planet. Picture the first humans who realised that those tiny lights above are not just holes in a dark curtain, but distant suns. Imagine the amazement and perhaps the fright they must have felt, sensing suddenly that the world is so much larger than it seems. But with that realisation also comes a profound opportunity for humility and connectedness. To know that the atoms of our bodies come from the stars can instill a sense of belonging in the universe. We're children of the cosmos, made from its raw elements, and to it we shall return when our life ends and our atoms disperse to become new forms. This cycle of matter is like a great wheel, turning slowly over eons. Life and death, stars and galaxies, all bound together. So on this journey, as we float through the quiet starlit void, consider that you are both a traveller and at home. You travel through space on a tiny planet, Yet you also carry within you pieces of every place you have ever been. In a way, you are home to particles of distant stars and perhaps even distant galaxies, which drifted and eventually became part of Earth. The cosmos is not just around you, it is within you, sleeping in your cells, awakening in your thoughts, and breathing in your breaths. With each gentle inhale and exhale, you trade atoms with the air and the world, blurring the lines between you and the outside. Over a lifetime of breaths, you will inhale trillions of atoms that once belonged to others, other people, other creatures, even other worlds. The same is true for them inhaling what was once part of you. In this great exchange, the universe mingles itself, all things sharing the same cosmic air. This awareness can be a kind of meditation. Breathing becomes not just a simple act of survival, but a communion with ancient elements. Looking at the stars becomes not just sightseeing, but greeting ancestral lights that are kin to our very substance. A gentle breeze on your skin at night might remind you that the atmosphere wrapping around our world is itself a product of life interacting with cosmic forces. The oxygen from ancient trees, the nitrogen from distant cosmic events, all blending to cradle us. We are cradled not only by the Earth, but by the cosmos at large. Starlight, gravity, and elemental cycles nurture us each moment. And in gratitude, we pay attention. We listen to the night. The cosmos has a way of inviting our attention inward, even as we gaze outward. In the darkness, as your eyes adjust, more stars emerge from hiding. Likewise, as you become still, thoughts settle, and a deeper sense of self can emerge from within. It is in those moments that the concept of cosmic consciousness becomes more than an idea. It becomes a felt experience. Perhaps you notice that your heartbeat is steady and calm, echoing gentle rhythms found everywhere in nature. The pulsing of crickets in the night, the slow flare of variable stars. You might sense that your mind, quieted, is as vast as space itself, with thoughts appearing like distant twinkling stars in the expanse of your awareness. This state of calm, serene reflection, where inner space and outer space seem to touch, is a precious experience. Many seekers of truth, philosophers, monks, poets, and scientists alike, have spent nights under the sky, seeking that sensation. Some have described feeling dissolved into the stars where the boundary of self falls away, and only unity with all things remains. Others have found, in the cosmic view, a perspective that heals, an understanding that our troubles and worries, however heavy, exist in a much larger tapestry of existence. Not to diminish the importance of our lives, but to realise that we are part of something vast and enduring can make those burdens easier to bear. It is as if the stars quietly say, "You are not alone. You are part of this great story." Even the silence out here feels alive with meaning. Drifting in the cosmic ocean, one can sense the echoes of ancient explosions, the glow of faraway suns, and the soft presence of unseen matter that gently sways galaxies. We know through science that space is not truly empty. It's filled with invisible fields and particles popping in and out of existence. But even without knowing those details, one can feel that emptiness is full of possibility. In a way, the emptiness between stars is like the silence between notes of a lullaby, integral to the music, giving it depth and resonance. The quiet of the cosmos is the canvas on which all celestial light is painted. In this serene hush, a question naturally arises. What does it all mean that we are here, able to witness this grand tableau? It's a question both deeply personal and profoundly universal. Perhaps the meaning is simply to witness it, to marvel, to learn, to feel. Perhaps it is to connect, each conscious being, a bridge between the stars, sharing in the universe's self-discovery. Or maybe meaning is a human construct, something we create to comfort ourselves in the face of infinity. And yet, even if that is so, there is comfort indeed when you stand beneath the sky and feel awe and reverence. That feeling is its own justification. In that moment, nothing more is needed. You and the universe are in silent conversation, and that is enough. Our awareness, as small as it seems, becomes a precious vessel carrying the universe's memory. In our minds, we hold the history of stars, the chronicle of how a universe coalesced into galaxies and how on at least one world, life emerged to see the stars. That narrative lives on as long as we remember and tell it. In a way, the cosmos ensures its own story continues by instilling curiosity in us. Every time you feel compelled to look up and wonder, it is the cosmos nudging you to remember where you came from. Each of us is a storyteller on behalf of the universe, whether we speak through science or art or simple gazing wonder. And so, as this reflection on cosmic consciousness flows gently onward, consider how extraordinary it truly is. For a few brief moments in cosmic time, the matter in these hills and oceans coalesced into beings who could feel love and wonder. For a brief era, there are eyes open to see the night, ears to hear the wind in the trees, minds to ponder existence. It may not happen everywhere or often in the universe, or perhaps it does. We do not yet know. But here and now, it is happening through us. By simply being aware, we fulfill something fundamental about the universe. We give it eyes and ears, thoughts and emotions. Out in the dark sea of space, our planet glows, a delicate blue, alive with this awareness. If one could drift high above, one might see Earth as a small lantern of life, flickering with the collective light of billions of souls. Each soul is like a candle, and taken together, they make a radiant glow that could be sensed if you were near enough. In that metaphor, humanity and all life on Earth are the cosmos gathered into a brief, bright island of knowing and feeling. And though each candle may eventually dim, others will light in succession, continuing the luminous chorus. The light of consciousness, once lit, has a way of spreading, just as one flame ignites another. It's calming to realise that we belong to this continuum. The cosmic perspective doesn't make us insignificant. It makes us invaluable participants in a cosmic unfolding. We may be tiny, but like a tiny neuron in a vast brain, we have our role in the grand awareness, and collectively, perhaps all conscious beings across the universe, if there are others, form a kind of network of awareness spanning the galaxies. Even if we never meet them, even if those distances remain unbridged, just knowing they could exist expands our sense of family. Under the same stars in a different sky, others might wonder and hope just as we do. The universe might be quietly full of such secret sparks of knowing. However, even if we are alone in our galaxy in this moment, that does not diminish the miracle of being here. In fact, it places a gentle responsibility on us to keep the flame of awareness alive, to explore and to cherish, to keep telling the universe's story, so it won't be lost in silence. Each lullaby about the stars that we whisper to a child, each question we ask about the cosmos, each dream we have of distant worlds is part of that responsibility. It is how we honour the gift of consciousness that the universe has through countless trials and wonders given to us. Now, as we float further into this thoughtful night, let the sense of cosmic consciousness gently fade into the background like soft music. It will remain with us as an undercurrent. We carry that awareness onward as we turn to another layer of the cosmic mystery, just as we have looked out into the vastness and felt a grand unity. We can also look inward into the minuscule and fine wonders, no less profound. Our journey continues seamlessly from the very large to the very small, for the two are connected, like reflections in a mirror. At the smallest scales of existence, a new kind of mystery and wonder unfolds as we shift our gaze from the immense to the infinitesimal. We enter the realm of the quantum, a world where the rules of everyday reality seem to fade into a dream-like haze. Here, particles flicker in and out of being, and certainty dissolves into possibilities. In this microscopic domain, we find that everything solid is mostly empty space, and what we think of as matter is composed of tiny, flickering energies whirling in vast gaps of apparent nothingness. It is as if the cosmos, when examined up close, is built not of bricks but of whispers and probabilities. Imagine shrinking down into an atom, drifting past electrons that swarm not like planets around a sun, but like a diffuse cloud of potential, here and there at once, until observed. In this tiny universe within the universe, an electron can be almost everywhere and nowhere in particular. Only when we try to pin it down does it seemingly make a choice of where to be. This is the strange dance of quantum mechanics. Particles behaving sometimes like solid points, other times like spread out waves. A single speck of light, a photon, can act as if it travels many paths simultaneously, then settles on one path when we look. Reality at this level is not a fixed storyboard, but an improvisation, a play of light and shadow that only becomes concrete when it interacts with a consciousness or measuring instrument. It's a realm that invites us to question what is real and whether observation is woven into the very fabric of existence. This isn't chaos, but a different kind of order, one that defies our common intuition. In quantum realms, cause and effect can feel less straightforward. Two particles born together can become entangled, a mystical bond connecting them, no matter how far apart they fly. If one is gently nudged, the other responds, even if it is across the room or across the galaxy, instantaneously, as far as we can tell. It is as though the universe keeps secret channels between distant things, a private whisper that ignores the vast gulf of space. Experiments have shown this spooky connection to be real. Einstein himself famously nicknamed it spooky action at a distance, acknowledging how unsettling such instant linkage was to him. Yet every experiment since has confirmed that this mysterious connection is indeed real. It suggests that separateness might be an illusion, and that at a fundamental level, the cosmos is deeply interconnected in ways we are only beginning to fathom. In the quiet of our journey, think of what this means. The very particles in your body might have subtle links to particles far away. Perhaps an atom in your hand is quantum connected to an atom in a star a million light years distant. While the specifics of entanglement don't usually persist in our complex bodies, the idea symbolises a truth that everything emerged from the same cosmic beginnings. In the moments after the universe was born, all was one blazing soup of particles intermingling. As the universe expanded and cooled, those particles drifted apart to become galaxies, stars, planets, and eventually us. Yet on an underlying level, they remember a time when they were together as one. The echo of that unity may still live in the quantum language they speak. Not only distance, but time too behaves oddly in the quantum world. Particles pop into being and vanish, as if borrowing energy from the future and returning it an instant later. This constant fluctuation, sometimes called quantum foam, means even empty space is teeming with subtle activity. What appears as a void is more like a sea of virtual particles, momentarily alive then gone, like transient thoughts in the mind of the universe. Perhaps this is the source of creativity in nature, the way new possibilities emerge. From this foam, entire universes might have budded off, or the seeds of galaxies might have been sown. On a smaller scale, these tiny fluctuations are happening around us and within us all the time, unnoticed yet essential. They provide a backdrop of possibility from which more stable things, like atoms and molecules, can form and exist. And within the heart of a star, quantum magic enables life-giving light. In the sun's core, where temperatures and pressures are immense, atomic nuclei fuse together, releasing energy that eventually radiates out as sunlight. But curiously, the nuclei in stars are often not energetic enough on their own to overcome their mutual repulsion. It is the quantum trick of tunneling, the ability of particles to slip through barriers as if by ghostly permission, that allows the sun and stars to shine. Two hydrogen nuclei can fuse into helium because, in the quantum realm, there is a small chance they simply find themselves together, bypassing the usual obstacle. Without this chance, the stars might never ignite, and the cosmos would be dark and lifeless. Thus, the everyday sunshine that warms your skin is rooted in the uncertainties of the subatomic world. The quantum and the cosmic are intimately linked, each dependent on the other, to exist in the form we know. Consider for a moment that your own existence hinges on these delicate improbabilities. The particles in your heart and brain obey these strange laws. At every moment within you, electrons jump in atoms. Enzymes facilitate reactions by quantum quirks. Even the very sense of smell you have might involve electrons tunneling in receptors. We go about our lives unaware that the utterly bizarre is happening in every cell. Yet here we are, large and stable, classical creatures in a quantum-built body, marvelling at the stars. It is as if nature hides its magic beneath a veil of normalcy, so we are free to live and wonder without being overwhelmed by constant paradox. But on nights like this, while contemplating the cosmos, that veil thins just a little. We remember that the ground of reality, the foundation of everything, is a mystery that goes beyond our full comprehension. Some have wondered if consciousness itself is tied to this quantum strangeness. Could it be that the mind, in its ability to jump from one thought to another, or in the feeling of free will has something quantum about it. This is a speculative idea, and yet it's intriguing to think that the gap between an intention and an action might be a kind of quantum leap. Whether or not that is true, what we do know is that our brains operate with electrical impulses and chemical signals that are ultimately governed by those same microscopic rules. So, in a way, the thoughts you have, even this very experience of calm reflection, are enabled by subatomic particles doing their quantum dance in your neurons. We are quantum beings as much as we are cosmic beings. The dual nature of particles behaving as both material and immaterial has a philosophical echo. We too are flesh and spirit, physical, yet filled with intangible feelings. The quantum world shows that reality is not simply material or energy, but something more subtle, something that can manifest as tangible matter or as spread out potential. Similarly, within us, there are tangible aspects like our bodies and intangible ones like dreams, thoughts, and consciousness. Perhaps the line between what is physical and what is not is more blurred than we think, just as the line between particle and wave is blurred for a photon. In the smallest of spaces, the categories we take for granted break down, inviting us to embrace uncertainty and paradox as fundamental parts of nature. All of this might sound bewildering, but in the gentle context of our cosmic journey, it can also be quietly wondrous. It tells us that there are layers of reality, stacked in ways our senses alone cannot reveal. If the cosmos were a grand mansion, our everyday experience is like living in just one beautifully furnished room. Science has opened doorways to other rooms, showing us that beyond our normal view there are wonders. Some behave like funhouse mirrors, where up can seem down, or like secret passageways, connecting distant halls. It's as though the universe enjoys a bit of playful mystery, keeping surprises tucked away in the very structure of existence. As our minds absorb these reflections, let us gently step back from the quantum world. We zoom out from the tiny atoms and return to the realm of the visible and tangible. See in your mind's eye the scene expanding, from subatomic particles to atoms, to grains of sand, to a human hand, to the entire person, to the environment around, and finally back to the open night sky overhead. The stars still sparkle calmly, seemingly unchanged by the bizarre truths we uncovered beneath the surface. And indeed, for ancient travellers and poets, these details were unknown. What they experienced was a sky of reliable patterns, guiding lights that turned with the seasons, year after year, faithful and familiar. So now, as if rising from that subatomic reverie, we turn our attention back to the human scale under the open sky, to the wisdom of those who came long before, who navigated the cosmic seas without ever knowing the word quantum, but who connected to the cosmos through stories and practical knowledge of the stars. Long before modern instruments and charts, humans learned to read the night sky as if it were gentle instruction from the cosmos. Imagine a vast ocean centuries ago. A Polynesian voyager stands at the helm of a canoe, carved from an ancient sacred tree. All around is the dark water below, and above, an astounding sprawl of stars. There is no land in sight, only the swell of waves and the dome of heaven. Yet this voyager is not lost. As the sun set, they noted the first star to appear on the horizon, a familiar friend, marking the direction of home. Through the night, they will navigate by the rising of specific stars, each guiding them along a memorized path across the sea. With no compass but the sky itself, they trust in a map written in starlight, passed down through generations. In the gentle rocking of the canoe, one can almost feel how the navigator's senses extend beyond the boat. The navigator feels the pattern of swells now against the hull, the cool wind shifting, and overhead the constellations slowly rotate. They carry in their mind a starry compass, a mental chart of where key stars rise and set along the horizon. As one guiding star climbs high and drifts westward, the voyager's eyes move to the eastern horizon for the next star that will take its place in guiding the way. All through the night, this relay of stars keeps the canoe on course. The voyager might softly chant an ancient song that names each star and its role, the melody itself a tool to remember the route. There is serenity in this wayfaring. The ocean and sky are not adversaries, but trusted companions on the journey. The North Star, called Polaris, has long been a steady beacon for travellers in the northern world. In the sky it barely moves, holding nearly still while the other stars wheel around it. For sailors and wanderers, this fixed point offered reassurance, a cosmic lighthouse shining no matter how dark the night. Many a traveller has looked up, found Polaris, and felt a wave of relief, knowing the direction of north with certainty. In the southern hemisphere, where Polaris cannot be seen, navigators turned to the Southern Cross, a cross-shaped grouping of stars and the two pointer stars near it, to infer the location of the south celestial pole. Even without a single bright star to anchor the sky, the pattern of those stars provided a reliable guide. No matter where one stood on Earth, the sky was a compass for those who knew its secrets. These techniques were often safeguarded and taught within families or guilds of navigators. In some cultures, the knowledge was considered sacred. After all, the ability to cross a vast ocean and return was a matter of life and death. It required not only skill, but a profound relationship with nature. The navigator had to attune themselves to subtle cues, the colour of the twilight, the direction of swells which might hint at faraway land, the flight paths of birds at dawn, returning to roost on islands over the horizon. Each sign was read in conjunction with the stars. It is a testament to human ingenuity and trust in the cosmos that people voyaged for thousands of miles this way, long before sextants or modern navigation tools. Consider an image of an elderly Pacific Island wayfinder teaching a young apprentice under a dome of brilliant stars. They lie on their backs in a canoe, moored in calm lagoon waters, the elder's weathered hand pointing out the star paths. With each gesture, they recount a story, how this star was named, for a particular ancestor, how that constellation looks like a fishhook used by a demigod to pull up islands from the sea. The apprentice listens and watches, eyes tracing the invisible lines drawn by the teacher's words, connecting star to star. They feel the warm night air, hear the gentle lapping of waves, and absorb the knowledge that will one day keep them alive on the open ocean. In teaching navigation, myth and practical wisdom merge seamlessly. The stories serve as both mnemonic and moral, embedding important navigational cues in a narrative that can be easily remembered and passed on. And indeed, for people everywhere, the night sky became a grand tapestry of stories. Long before television or books, our ancestors looked upward for storytelling inspiration. They saw figures of legend, among the stars heroes, monsters, gods and animals, their dramas playing out night after night in slow motion as the seasons changed, which stars were visible. The patterns we call constellations were like a global picture book, with different cultures, drawing different pictures from the same points of light. What one saw as a great bear, another imagined as a mighty hunter, and yet another as a celestial canoe. For example, in Greek mythology, the constellation Orion is known as a great hunter with a shining belt of 3 stars. He chases eternally across the sky, accompanied by his faithful dog, the star Sirius, brightest of night. To the ancient Greeks, Orion's setting, when he dipped below the horizon, signified the time of year when scorpions, represented by the constellation Scorpius on the opposite side of the sky, rose, as if the scorpion that once stung him still pursues him among the stars. Meanwhile, many Pacific Island cultures saw a different picture in some of those same stars. In one Polynesian interpretation, Orion's belt and nearby stars form the outline of a great canoe. In this way, the heavens reflected their seafaring life. The Pleiades star cluster is another celestial wonder wrapped in story. To the naked eye, in a clear, dark sky, one can see 6 or 7 tiny stars clumped close together, like a little sprinkle of diamonds. Almost every culture noticed this cluster and wove tales about it. To the Greeks, these were the 7 sisters, daughters of a Titan, pursued by Orion, or turned into stars to escape grief or chase, depending on the tale. In Maori tradition in New Zealand, the cluster is called Matariki, and its rising in winter marks the beginning of the new year, a time of remembrance and planting for the coming spring. In Japanese, they are Subaru, a name you might recognise, as even a modern car brand pays homage to the cluster's unity of stars. In many Native American traditions, there are stories of 7 siblings or friends who became those stars. One beautiful tale from the Cheyenne people speaks of 7 children who fled to the sky to escape a bear forming the Pleiades. And the bear became the nearby Big Dipper stars. Such stories, while varied, show how universally this little cluster captured human imagination. When people far apart in time and space all felt compelled to explain the same pinwheel of tiny stars with narrative, it underscores a shared human desire to connect the dots of the sky into something meaningful. The Milky Way itself, the ribbon of diffuse light arching overhead, was often interpreted as a path or river. Some called it the River of Heaven, imagining that souls travelled along it to the afterlife, or that gods crossed it as a shimmering bridge. Others saw it as spilled milk from a goddess, or as strewn hay from a celestial horse's feeding sack. In a Chinese tale, it is the silver river that separates 2 lovers, the star Altair, a cowherd, and the star Vega, a weaver girl, who are allowed to meet only once a year when a bridge of magpie birds forms across the Milky Way, allowing them to reunite. That story is still celebrated on a summer night each year, when people look up and remember the lovers. Meanwhile, in a different land far away, people told a very different kind of sky story. In Australia, some Aboriginal peoples look at the Milky Way not by its stars, but by its dark patches. against the glowing, starry bands, they see the shape of a great emu stretching across the sky. The emu's head is a coal-black nebula near the Southern Cross, and its body follows the Milky Way's misty path. This sky emu is woven into their traditions. When it appears in a certain posture at dusk, it signals the season to gather emu eggs. The dark voids of the galaxy become a giant bird in their imagination, connecting the cosmos to their way of life. This creative vision shows that human imagination finds meaning not just in stars, but in the darkness between them. Through stories, the stars became more than just lights. They became reminders of lessons, of morals, of cycles of nature. A constellation, representing a hero, might remind people of courage during difficult times. One representing a farming tool or animal might signal when to plant crops or hunt game. The sky was a calendar and a compass combined with a storybook. As useful as it was inspiring, the myths served multiple purposes: entertainment, moral guidance, and practical knowledge, all encoded in one. Consider also the experience of a child in ancient times, looking up on a clear night, while an elder pointed out the constellations and recounted their tales. The child's eyes might move from star to star as the figures come alive in imagination, perhaps seeing the mighty shape of Orion or the arc of a scorpion's tail. They hear how those stars came to be. Maybe a story of love or bravery or transformation. In those moments, the child is not only learning the sky's map, but also absorbing a sense of belonging to a larger narrative. They learn that the same stars were watched by their ancestors, that the same tales are passed down, and thus they too are part of this continuity. The stars tie generations together as each retelling of a constellation story rekindles the memory of those who first told it. All the while, the night gently turns, the earth rotates, and new stars rise in the east, while others set in the west, making the sky dynamic. Over months, the constellations shift with the seasons. Our ancestors noticed this, and the sky became their seasonal clock. The appearance of certain stars at dawn or dusk signalled planting time or harvest, migration of herds, or the flooding of rivers. For example, the ancient Egyptians watched for the rising of Sirius just before sunrise, which heralded the annual flooding of the Nile, crucial for their agriculture. To them, this star was linked to the goddess Isis and the cycle of life, death, and rebirth of the land. Thus mythology, agriculture, and early astronomy intertwined. Navigators, storytellers, farmers, and priests alike studied the sky, albeit with different aims. But whether they sought to find their way across open ocean, to explain the mysteries of existence through tales of gods, or to predict the change of seasons, they all treated the sky as a trusted guide. It loomed above as a constant presence that anyone could observe. Over generations, careful observation and rich imagination turned into traditions of knowledge. Even today, there are those reviving and practicing these ancient arts. In the Pacific, navigators have begun again to sail voyaging canoes without modern instruments, trusting the stars, waves, and winds as their ancestors did, proving the old ways still hold. Such journeys are as spiritual as they are technical, reaffirming a bond with nature and heritage. We might think in modern times that we have moved beyond those star stories, replacing them with scientific fact. But on a quiet night, even now, if you gaze long enough, you might find your mind drifting into old patterns, seeing the shape of a hero here, a mythical creature there, or recalling a legend you heard once about a constellation. Our fancy for stories never truly leaves us because it's woven into how we perceive patterns and meaning. Science, in its own way, has continuity with these ancient impulses. Both are driven by curiosity and the urge to find connections, where an ancient myth maker connected stars to craft a tale. A modern astronomer connects data points to form a theory. Both are creating narratives to describe and predict the workings of the world, one through imagination, the other through mathematics and observation. Under the stars, the boundary between practical navigation and spiritual journey often fades. Many cultures believed that gods or spirits literally inhabited the stars, or that ancestors became stars when they passed on. A voyager might feel that their ancestors were watching over them in the sky, guiding them along. The night sky could be both compass and cathedral, a place of direction and of worship. Even today, away from city lights, one can feel a natural reverence gazing up. It is as if something in our very old memory recognises the importance of that view. We might not remember the specific star lore of our distant forebears, but the feeling of wonder and respect is ingrained. Now, as the ancient stories and methods swirl in our thoughts, we can appreciate how human understanding of the cosmos evolved. We move from seeing patterns and telling tales to measuring and hypothesizing. Yet we should not think of it as discarding one for the other, but rather adding layers. The starry sky that once solely told myths now also tells us about galaxies and physics, but the myths can still live on in our cultural heritage. In a way, the cosmos has always been a canvas for our minds. What changed over time was the brushstrokes we used. At first painting with mythic imagination, later with scientific reasoning. Ultimately, both pictures reflect our desire to engage with the cosmos. Humanity's relationship with the stars has been both practical and poetic. The night sky guided our voyages and also our dreams. With those dreams in mind, we drift onward, from the tales of old to the ways we seek understanding today, blending myth and science in the ongoing story of our connection to the universe. For centuries, myth and science have danced around each other, like twin stars orbiting a common centre, the human desire to understand. Myths were our first brave attempts to explain the bewildering and the beautiful. Before we had equations, we had stories. When thunder roared, we spoke of gods. When comets streaked the sky, we imagined dragons or omens. These tales were not foolish. They were our early wonder, given narrative form. They comforted us, taught us and piqued our curiosity. They also spurred practical knowledge. Ancient peoples marked the passage of seasons by the stars. They built great circles of stone and pyramids of rock aligned with celestial events. Think of Stonehenge in England, catching the sunrise of midsummer, or the pyramids in Egypt, aligned to north like giant compasses, or the temples of the Maya precisely tracking the cycles of Venus. Such structures required careful observation and record keeping, an early scientific mindset, inspired by the skies. Even without modern instruments, our ancestors mapped the heavens with remarkable accuracy, blending their mythic narratives with empirical timing. The sky was their textbook, and their scripture both. In truth, the boundary between myth and science is porous. Think of the ways we often personify scientific concepts. We talk about the angry red planet Mars, or the elegant dance of binary stars, or the generous sun giving life. These are metaphors, little mythic flares in our language, acknowledging that there is poetry, even in facts. We name constellations after ancient heroes, and planets after old gods, as if deep down we know that myth and science are both part of one continuum of meaning. We even send our scientific creations to the heavens bearing mythic names. Rockets named for Saturn, spacecraft named Juno or Apollo, rovers named for goddesses of dawn. It's as though we cannot resist linking our newfound knowledge back to familiar stories, because those stories are our cultural heartbeat. Consider how every scientific theory begins as a spark in the mind. Newton, watching an apple fall and pondering if the moon falls around Earth in the same way. Einstein picturing himself riding a beam of light. These pivotal moments are acts of imagination. They became science after rigorous thinking and testing, but they started in the realm of creativity, not so different from dreaming up a myth. And like myths, sometimes scientific ideas sound incredible at first. The Earth moving around the sun, invisible forces of gravity, time dilating with speed, holes in space swallowing even light. These could be plot points in a fantastical story, yet they are our reality, proven and accepted, but no less wondrous. In communicating these discoveries, scientists often must become storytellers themselves, crafting narratives that guide others to understand truths that are not immediately visible. Our modern explanation of the universe's origin, the Big Bang, is itself a kind of creation story. Instead of gods forging the world, we have a tiny hot seed that expanded outward, cooling and spawning galaxies and stars over billions of years. Instead of a single generation of deities, we have multiple generations of stars giving birth to heavier elements in their fiery cores and spreading them in supernovae, from which new stars and planets form. We tell of how our sun and earth coalesced from a swirling nebula, how life sparked in the oceans, how consciousness lit up in creatures that could then look back and tell the story. This grand narrative is pieced together by evidence and reason, but we string those pieces into a timeline that humans can grasp. A story with a beginning, however abstract, a dramatic unfolding, and ongoing chapters. There is even a hint of fate or destiny in the way conditions had to be just right for life, echoing anthropic musings that the universe in some way knew we were coming, though science would frame it as fortunate coincidence, filtered by vast numbers. Yet science is careful. It reminds us that, unlike fixed myths, its stories are provisional. If new evidence arrives, the story changes. Once we thought the expansion of the universe might be slowing, now we observe it's accelerating. So, our cosmic story gained a new mysterious element, dark energy, an unknown force, driving galaxies apart faster and faster. In mythic terms, one might call it an invisible, perhaps mysterious, spirit of expansion. In scientific terms, it's a puzzle to solve. Both ways we acknowledge there is something we don't fully understand, and we give it a name so we can talk about it. Dark matter and dark energy, the very act of naming them with the word dark reflects that we are casting about in metaphor to describe what is essentially the unknown. These are our modern mysteries and wonders, as profound as any ancient riddle. We have detected their influence, yet their true nature remains elusive. It is as if the cosmos is keeping secrets, ensuring that wonder and discovery are never ending. Just as myths spoke of hidden forces and realms, science now speaks of dark ingredients of the universe that challenge our understanding. We give them names as placeholders, but they humble us, reminding us that for all we have learned, there is vastly more we do not know. Perhaps future generations will unravel these secrets, turning the unknown into the known and finding new mysteries beyond, continuing the grand story. Imagination fuels both art and science. A cosmologist imagines how space might curve and warp, just as a painter imagines new worlds on a canvas. When we build telescopes to peer deeper into space, it's like adding new chapters to our cosmic story, filled with images that astonish us, galaxies colliding, nebulae glowing, with newborn stars, black holes with swirling disks like cosmic whirlpools. We often give these sights poetic names too: the Pillars of Creation, the Eye of God Nebula, the Butterfly Nebula, as if to tame the raw data with a touch of familiar beauty. The reality of them is natural phenomena, but our perception layers meaning and wonder on top, much as we always have. Think of how star lore and science education coexist today. A teacher might start a lesson by recounting how the Navajo see the Milky Way as a path of spirits, and then segue into how it is composed of billions of stars. The interplay makes learning rich and keeps our sense of wonder intact. We do not have to choose one or the other in our hearts. We can appreciate the scientific explanation while still feeling the poetry of the older tale. In fact, sometimes knowing the science deepens the awe. When we learn that the colours of a sunset come from light scattering, we might simultaneously recall a legend of the sun being painted by God's hand, and hold both thoughts with a smile, one foot in factual understanding, one in imaginative appreciation. Modern storytelling continues to expand our cosmic imagination. Through books and films, we conjure scenarios of interstellar travel, encounters with alien life, journeys through time. These are our new myths, projected into the future instead of the past, but they serve a similar role. They let us explore possibilities in the safety of imagination. What if we could sail among the stars as ancient mariners sailed the seas? What civilizations might exist on worlds circling those distant suns? These fictions spark the public's interest in actual science. Many scientists trace their inspiration back to a childhood book or movie that ignited their passion for the stars. In that way, storytelling propels understanding forward. Dreamers imagine it, and later, someone tries to build it. Indeed, the boundary between fantasy and reality is porous. Humans dreamt of flying to the moon long before rockets existed. And then one day, those dreams guided us to set foot on the lunar surface. What was magic became science. As we stand at the shore of the cosmic ocean, we can wonder which of our current stories, perhaps journeys to Mars or beyond, will be the next to come true. Every great endeavour is born from a narrative we believe in, even within the practice of science itself. The way we share discoveries often takes the shape of story. When cosmologists talk about the early universe, they describe phases. First light, cosmic dawn, the era of recombination. Cosmic inflation, terms that sound almost mythic. There's drama, initial chaos, rapid expansion, cooling, battles between matter and antimatter, triumph of matter, formation of structure, star birth, and star death. It's hard to escape a narrative structure because our human brains seek patterns and arcs. Good scientists remain vigilant about facts and evidence, but they use narrative as a tool to communicate and to hypothesize. In doing so, the cosmos becomes not just data points, but an unfolding saga we are part of. Throughout history, there have been moments when myth and science directly collided or converged. When Halley's Comet returned in 1910, some feared it as a bad omen, as in old myths, while astronomers calmly calculated its trajectory. When we first saw the surface of Mars through telescopes, some imagined canals built by Martians, blending observation with fanciful interpretation. That particular imaginative leap turned out incorrect, but it led to countless stories that in turn inspired real scientific searches for life on Mars. Even today, when a scientist ponders multiverse theories, countless unseen universes with different realities, one might say we are touching ancient ideas of innumerable other worlds or realms, akin to myths of other dimensions or spiritual planes. If the multiverse exists, then reality is layered beyond comprehension. Each universe a bubble with its own stars and perhaps its own forms of life, an endless foam of creation. It remains a scientific speculation, but it serves as a profound reminder that however far we push our understanding, there may always be more, a greater context we have yet to glimpse, an ever wider horizon of existence. In that sense, the daring leap of vision is similar across ages. We continually expand our conception of what might be, guided by both wonder and reason. There is a sort of harmony in acknowledging both sides of our nature, the analytical and the imaginative. Alone, science can become dry, and myth can become baseless. Together, they enrich one another. When the night sky makes us feel something profound, that is the domain of poetry. When we then measure the spectra of starlight to find their elements, that is science. Feeling and understanding, both are essential to a full relationship with the cosmos. We are not robots cataloguing stars, nor are we only dreamers ignoring facts. We are a blend, a species that uses mind and heart together. So as we gaze at the stars tonight in our journey, we carry with us both ancient and modern wisdom. We can admire Orion as the hunter of legend, and simultaneously as a giant assembly of stars, hundreds of light years away, including red Betelgeuse, nearing the end of its life, and blue Rigel shining hot and young. Knowing these facts doesn't diminish the constellations' allure. If anything, it adds another layer of meaning. The cosmos grows more complex and yet more personal the more we learn. Each discovery is like finding a new piece in an endlessly rich story. Let us also reflect on ourselves as storytellers. We have been doing it this entire time. This very narration is a form of storytelling, weaving facts and reflection into a narrative to share with you. In telling the story of the universe, we are engaging in one of humanity's oldest pastimes, passing knowledge and wonder from one person to another, whether around a campfire or through the medium of a screen or speaker. The essence remains. One being says to another, Listen, I have seen something amazing. Let me share it with you. In this way, each of us becomes both student and teacher of the cosmos, inheriting wonder from those before us and gifting it to those after us. As we prepare to explore the next realm of experience, the night has deepened and the outer world grows still. It's a natural time to turn inward. Let's hold close this union of myth and science, of imagination and reason. They will accompany us as we turn inward now to the realm of dreams and inner exploration, where the stories we tell meet the stories we live, and where the boundary between the universe out there and the universe within grows ever thinner. Night is the domain of dreams, as well as stars. As the body rests and the conscious mind dims, the inner cosmos of imagination awakens. It is not uncommon for our dreams to carry us to the stars. Have you ever dreamed of flying, weightless and free? Perhaps in one dream you step off your doorstep and find you're walking on the moon, the grey dust soft beneath your feet, and the earth glowing in the black sky above. In another, you might float in a small boat on a cosmic ocean, its waters made of stars and galaxies, gently rowing through constellations as though they were islands. In dreams, the laws of physics loosen. We can breathe underwater or soar through space, guided by subconscious whims. The cosmos that we study by day can become a playground of symbols and emotions by night, as our minds weave personal narratives, using the raw materials of our experiences and aspirations. Sometimes the boundary between a dream and a story we tell consciously is thin. In a way, dreams are our mind telling a story to itself, trying to make sense of feelings and observations in a language of metaphor. A person deeply passionate about the stars might dream of meeting an entity made of stardust, or of sailing a celestial sea on a ship of light. A scientist wrestling with a hard problem might dream of a fantastical scenario that, upon waking, inspires a real solution. History holds remarkable tales of discoveries gleaned from dreams. One chemist saw in his sleep the image of a serpent biting its own tail, a symbol of wholeness, and it revealed to him the ring shape of a molecule he had long sought to understand. And as a teenager, a young Albert Einstein dreamed of sledding down a steep mountainside at the speed of light. In that dream, the stars' light shifted to brilliant colours as he raced, leaving him with a haunting wonder that later blossomed into insights about light and time. Our nighttime dreams often borrow from the same well as our waking stories. The archetypes, the hero, the journey, the mystery appear in both, simply dressed differently. In a dream, you might not remember the exact figures from a myth, but the essence could be there. Travelling through darkness, hoping to find light, encountering something fearsome, and finding courage, or seeking knowledge, and receiving a revelation. These universal story patterns play out behind our closed eyes, just as they do in our literature. It's as if humans are natural storytellers, even in sleep, each night composing little plays in the theatre of the mind. And often, the stage set is cosmic. Dark skies, distant lights, unearthly landscapes. The space in which dreams occur is boundless, much like the outer space we gaze into. Perhaps this is why the quiet of night and the twinkle of stars are so conducive to drifting into dreams. The external environment and the internal state harmonise. There's also the phenomenon of daydreaming. You might find yourself staring out a window, mind wandering beyond immediate tasks, and suddenly you're imagining other worlds or future adventures. These gentle reveries are like controlled dreams, and many great ideas have sparked in such moments. A rocket scientist might have once been a child, daydreaming about riding a rocket. An astronomer might have been a youngster, imagining alien sunsets on far-flung planets. Storytelling often begins in these private musings, long before it is shared. By the time a writer or scientist puts pen to paper, they might have lived 100 imaginative journeys in their mind. Storytelling itself is a kind of dream that we agree to share. When you hear a story or watch a movie, you willingly suspend your everyday perspective and invites a new vision. Part of you knows it's fiction, yet another part reacts emotionally, as if it were real, much like in a dream. A well-told story about the cosmos can make your heart race at an astronaut's bravery, or ache at an alien world's beauty, or while you're snug in bed or curled up in a chair. Through stories, we collectively experience scenarios we never could individually. We simulate life among the stars, time travel, meeting beings from other worlds, exploring the unknown, all without leaving home. These experiences shape our cultural understanding of the cosmos. Even if they are invented, they prepare our minds to accept or even search for similar wonders in reality. Think of a time you heard a bedtime story about the stars. Perhaps a parent or grandparent pointed out the Big Dipper and then told you how it pours out the dew at night, or shared another fanciful fable. As a child, you likely absorbed that with wide eyes, letting it colour your perception of those stars. As you grew and learned the scientific explanations, the early enchantment might have faded in literal accuracy, but it probably left an emotional imprint, a fondness for the stars that remains within you. This is how storytelling contributes to cosmic understanding. By engaging our emotions and sense of wonder first, it ensures we care enough to pursue the facts later. We often need to love something before we invest in truly knowing it. Stories make us fall in love with the universe. Even now, this very journey we are on, speaking softly about the universe in a meditative narrative, is a form of storytelling. It mixes fact and reflection, reality and imagery, in a way not unlike a lucid dream. You are awake, yet you allow these words to paint scenes in your mind. The ancient navigator at sea, the drift through atomic worlds, the ancestors under constellations, and perhaps even yourself in a dream floating among stars. You might find that these images stick with you, and later, when you look at the night sky, they resurface, enriching what you see. You may recall that feeling of being connected, or the notion that those stars have stories within them, or that within your very being is the same substance as the stars. That is the subtle power of storytelling and imagination. It layers additional meaning onto reality, making the universe not just a collection of objects, but a living experience for us. In the grand tapestry of human knowledge, storytelling ensures that information is alive, accessible, and continuously reinterpreted. Scientific data becomes far more engaging when there's a narrative. Consider the way we frame the search for life on Mars as a story of exploration and hope, or the way we talk about the fate of the universe with a note of suspense. Will it expand forever, fade to black, or perhaps cycle anew? These narratives help us grapple with abstract concepts on a human level. Without them, raw facts might slip from memory, but a good story lingers. Many of us might forget the exact temperature of the sun's surface, extremely hot. But remember that it's often said the sun is a massive incandescent gas. From an old catchy song, a musical story of sorts. Memory and meaning are tied to narrative. There's also a deeply personal side to this. Each of us has our own cosmic story, a series of moments or experiences through which the universe became meaningful to us. Perhaps it was the first time you saw the Milky Way band on a camping trip, feeling suddenly small and awestruck. Or perhaps it was when you learned about the planets in school and imagined what it would be like to visit them. Maybe it was the moment you realise a loved one who passed away is, in a sense, returning to the stars, and that thought gave you comfort. These events weave together into your personal mythology of the cosmos. We might not often share these inner stories, but they guide how we relate to the night sky and the idea of the universe. Dreams and stories can also act as bridges across time. An astronomer today, using sophisticated telescopes, may still recall the myths that once explained the constellations she studies, aware that she's part of a long continuum from mythic storyteller to scientist. In dreams, time and space often mix. You might walk in a prehistoric landscape and then step into a futuristic spaceship in the next moment. Similarly, in storytelling, we traverse time scales with ease. We recount the birth of the universe and then imagine future galaxies millions of years hence. Our minds are not bound in the way our bodies are. They roam free, connecting past, present and future, probing both what was and what could be. Some say that reality itself might be a kind of story, a narrative woven by the cosmos. Whether or not that is true, it is undeniable that we make sense of reality through narrative. The cosmos gives us events and we string them into cause and effect, into history and prediction. In doing so, we find coherence and meaning. This is not to say we fabricate what is not there. Rather, we find the threads of connection that do exist and follow them, like following a plot. The story of how stars recycle material into new stars and planets is one such thread of connection. The story of how life evolves and becomes aware is another. When we share these stories with each other, especially in compelling ways, we collectively deepen our understanding. A fact that could be dry, like we are made of star stuff, becomes profound when framed as a story. Long ago, stars died so that you could be born. They exploded, scattering the elements that now form your body. It's the same truth, but delivered in narrative form. It touches a place in us that pure data cannot. In the quiet of a story or a dream, we often confront the big questions naturally. Children listening to a tale may suddenly ask, "Why are we here?" Or, "What are stars made of?" A bedtime story about the man in the moon might lead to wondering if anyone really lives on the moon. These gentle prompts show how stories open doorways to curiosity. Similarly, an adult might watch a science fiction film and come away pondering the nature of consciousness or the fate of civilizations. Thus, storytelling doesn't just feed us answers, it stirs up questions in an inviting way. It sets our minds on journeys of their own, which is exactly how understanding deepens. As we drift through this reflective night, allow yourself to value your own inner stories, the memories, dreams, and questions you have about the cosmos are part of your unique relationship with it. No one else has the same set of experiences or the same inner universe as you do. In a sense, each person's consciousness is a cosmos unto itself, rich with memories, which are like stars, feelings, like nebulas of glowing emotion, and thoughts, like comets darting in and out. We each carry a miniature sky inside, one filled with constellations of our experiences. This realization brings us to a thought that seamlessly ties the outer and inner together. The idea that the universe we observe and the universe within us might not be entirely separate. For all the vast distance and difference in scale, there's a reflective symmetry in patterns and in our pursuit of meaning. It is time now to explore that idea further, that inner space, the realm of mind and soul, is in many ways a mirror to the outer space of stars and galaxies. In that exploration, we find perhaps the deepest connection of all. Inner space and outer space, two grand frontiers that at first seem entirely different, yet they reflect one another in uncanny ways. Look up at the night sky. You see countless stars scattered across the vast darkness around you. Now close your eyes and look within. You find thoughts and memories twinkling in the darkness of your mind. There is a structure to the cosmos at every scale. Galaxies form filaments and clusters, arranged almost like a cosmic web, with great voids between. Curiously, if you look at neural networks in a brain, the pattern can appear strikingly similar. Neurons connecting in complex webs, transmitting signals across emptiness. One could almost imagine that a brain cell and a galaxy, different by trillions upon trillions of times in size, rhyme with each other in form. It might be coincidence, or it might hint at a deep principle of nature repeating patterns, as if the universe likes to reuse a beautiful design in varied contexts. Think of the numbers. There are, on the order of 100 billion stars in our galaxy, and coincidentally, about 100 billion neurons in a human brain. Is it just chance, or does it speak to the vast and endless potential of complexity both out in space and inside our skulls? Perhaps it is merely poetic parallel, but it fuels the imagination to think consciousness and cosmos might be parallel processes. Each of us carries within our head a structure as intricate in its own way as a galaxy. When you ponder the stars, there's a galaxy of neurons in your mind, firing patterns that correspond to that thought. It is as if one vast system is reflecting on another. Our ancestors had an intuition about this mirroring. As above, so below, they would say, suggesting that the patterns of heaven are echoed on earth. In modern understanding, we see echoes of that sentiment in fractals and repeating natural designs. Spirals swirl in galaxies millions of light years wide, and similar spirals shape the shells of snails, the pattern of a hurricane on Earth, and even the twisting double helix of DNA. Spheres are the shape of planets and also of cells and seeds. The pull of gravity makes planets round the pull of surface tension, makes a rain droplet round. Coincidence or cosmic rhyme? Such patterns remind us that we are not separate from the universe, but part of its continuous creativity. Consider your very body. It is composed of the same elements found across the cosmos. We often recall that we are made of star stuff, think of it in detail. The iron in your blood was forged in the explosion of a supernova long before the Earth existed. The calcium in your bones was brewed in the belly of a star. The oxygen that fills your lungs each moment was produced by generations of plants under the sun's light. But the atoms of that oxygen were formed in ancient stars as well. In essence, your inner space, the matter that makes you alive, is literally the ashes of long dead stars given new form and life. When you contemplate that, the boundary between you and the cosmos becomes blurry. You are a walking universe in miniature, with pieces of galaxies and stars inside you, dancing to the rhythm of life. Even the processes within us echo cosmic events. The electrical impulses in our nerves and brain are akin to lightning or the solar flares of the sun, scaled down to microscopic intensity. The heat in our bodies is a tiny echo of the nuclear fusion in stars as we burn calories in a controlled biochemical fire to stay warm and alive. The water circulating in our veins and cells once cycled through ancient oceans, clouds, and perhaps comets that delivered water to the early Earth. The salt in our tears and blood is from the primordial sea that nurtured the first life, an echo of the ocean that once enveloped all living things. And the sea's tides answer to the gravitational pull of the moon, linking our internal chemistry to the movements of celestial bodies. Our lives are tuned to cosmic rhythms. Day and night, governed by Earth's rotation, deeply affect our biology. In the daylight, stimulated by the sun, we are alert. At night, under darkness and starlight, our bodies release hormones that invite sleep. We carry an internal clock, a circadian rhythm that is essentially the echo of Earth turning under the sky. The moon's cycles have been observed to sway the behaviour of various animals, maybe even our own moods, a subtle monthly rhythm that mirrors the moon's journey around us. Across seasons, as Earth orbits the sun, we experience changes in weather and length of days, which shape our inner emotional landscape and energy. Many people feel uplifted as spring returns and the world warms, or reflective in autumn as days shorten. These are inner experiences directly tied to cosmic motions. Contemplate also the depths of time. The universe measures time in billions of years, the spans of star lifetimes and galactic dances. Our human lives, by contrast, span mere decades, a fleeting tick in cosmic terms. But time is relative to the beholder. For a butterfly that lives only a summer, that season is a complete lifetime filled with sunshine and purpose. For an ancient star, burning for 10 billion years, a million years might feel like a moment of its existence. We, somewhere in between, perceive years and centuries as significant stretches. Yet in those brief years, we experience love, learning, and wonder enough to fill a universe. In this way, the ephemeral and the eternal coexist. Every short life is a microcosm of meaning against the backdrop of cosmic eons. Knowing how short our time is can make each day more precious, and knowing how long the cosmos endures can give us comfort that life and memory persist in some form. Even after we are gone, our atoms will rejoin the earth and sky, and time will continue weaving new tapestries. We thus partake in eternity, each of us a brief but beautiful theme in the endless cosmic symphony of time. Our lives are also part of cosmic cycles in another sense. Many cultures talk of a circle of life, And indeed, we see cycles everywhere. Day giving way to night, winter to spring, the phases of the moon, the rise and fall of civilizations. These cosmic rhythms and cycles of days, moons, seasons and ages remind us continually that we are part of something much larger than ourselves. The cosmos also influences how we see ourselves in a more philosophical sense. We project human concepts onto the stars: love, war, heroism, fate, and the stars in turn influence our concepts by their very existence, challenging and expanding our understanding. We saw how myth makers did this explicitly. Now scientists do it in a different way. We contemplate the eventual fate of the universe. Will it collapse or drift forever? And it informs our philosophies about permanence and change. We learn that even stars are born and die, and it comforts us that death is part of a natural cycle, even on the grandest scales. We realise Earth is not the centre of the universe, and it humbles us, influencing religious and existential thought. It's a dialogue. We ask questions, the cosmos answers with discoveries, and those answers pose new questions in our minds. On a very personal level, many people use metaphors of outer space to describe inner feelings. We say, I need space, when overwhelmed, as if a mental equivalent of a starry expanse is needed to feel free. We feel starry-eyed in love, as if filled with bright lights within. Deep sadness can feel like a black hole that nothing escapes. A burst of inspiration might feel like a supernova in the mind. These are poetic, but they show how entwined the imagery of cosmos is with our vocabulary of emotion. It's as if our psyche borrowed the universe's language to articulate its own mysteries. These reflective connections between inner and outer extend even into how we search for meaning. We contemplate and personify the cosmos, and in turn those cosmic realities challenge our perceptions of meaning. We saw how myths personified planets as gods. Now the discovery of how small Earth is in the cosmic scale forces us to find meaning, not in being the centre, but in being part of a vast community of worlds. The interplay goes on. We ask, we learn, we adapt our inner worldview. Meditation is a practice that often explicitly unites inner and outer. Many meditation traditions encourage envisioning oneself as expansive as the sky, or to observe thoughts as clouds passing in the vast space of the mind. This analogy works because we innately sense that inside us is not just a cramped interior, but an open field of awareness. When you sit quietly and let go of the constant chatter, you may begin to feel your consciousness widen and become more still, like the night sky. Thoughts come and go like shooting stars or drifting clouds. In deep meditation, practitioners sometimes report a loss of the boundary between themselves and everything else, a direct encounter with that unity we have been contemplating. They might feel, even if briefly, that they become one with the universe, or that the universe is meditating through them. Even in a simple relaxation, you can gently taste a hint of this unity. For a moment, focus on the feeling of your body against the surface you rest on. Feel the pull of gravity which roots you to the earth. It is the same force tethering the moon in its orbit and guiding planets around the sun. Take a slow breath, and as you exhale, imagine any tension in your feet dissolving into the ground. Your toes and soles soften, and your ankles loosen. With the next exhale, Feel your calves and knees. Release any tightness. Your legs becoming comfortably heavy and warm. Breathe again and let go of any holding in your hips and lower back. The earth is cushioning you. You can surrender your weight to it. Let your belly relax and your chest remain open as you breathe. Feel the steady rhythm of your heartbeat, steady and calm, like the gentle ticking of a cosmic clock within you. Allow your shoulders to drop, freeing themselves of the day's burdens. Your arms and hands rest easily at your sides, tingling with relief. As you breathe out once more, feel your neck and jaw unclench and relax. Your face softens and your eyelids grow heavy. From head to toe, a wave of ease flows through you, as if a stream of starlight were washing gently over your body, coaxing every muscle into rest. In a more everyday sense, simply closing your eyes now and taking a slow, deep breath can be revealing. With eyes closed, the visual outer world is gone, but you are not gone. You find yourself in a space of darkness, with perhaps soft glows of colour from your optic nerves, a faint, ever-present inner light. Your sense of touch still tells you where your body is, but your mind can also float somewhat free of those confines. In that darkness behind closed eyelids, you might imagine the night sky. You can place a star in your mind's eye, and it will appear. You can conjure the earth, floating in space, and see it with inner vision. This simple ability suggests that inner space can hold the outer space as an image, like a mirror, reflecting it. The canvas of the mind is vast and capable of holding the whole cosmos in reflection. Now consider dreams again here. In a dream, your inner space creates an outer world for you to experience. It might be as boundless as the cosmos or as intimate as a small room, but while it lasts, it feels real. The material of that world is your own mind, yet you walk through it as if it were external. What is this if not a hint that inner and outer are made of the same stuff in different arrangements? The waking world has consistency we share collectively, while the dream world is personal and ephemeral. But both appear to consciousness and can shape consciousness. Some philosophies, especially in Eastern thought, suggest that the waking reality too is a kind of shared dream, or that consciousness is the fundamental substance of which matter is a manifestation. In those views, everything is essentially happening within one universal mind, and our individual minds are like eddies in that great stream. Modern science doesn't endorse a specific metaphysical stance like that, but it's a poetic contemplation that resonates with a sense of unity we've been exploring. Even if one doesn't subscribe to such ideas, there's no denying the interplay, the material universe created, the conditions for consciousness through life and evolution. And now, consciousness in us examines and contemplates the material universe. It's a loop, like a serpent biting its tail, reminiscent of that dream image which revealed a truth. The universe and consciousness are entwined in a dance, each giving rise to new forms and understandings in the other. With this perspective, one might ask, is it the universe that dreams through us, or we who dream of the universe? Perhaps both. When you imagine distant galaxies or aliens or futures, the universe is imagining itself through you. When a star somewhere goes supernova, and its light eventually stirs awe in an astronomer's heart, the universe is experiencing its own grand event through the intermediary of that awareness. It's a poetic way to see things, but comforting in its symmetry. Our joys, fears, and aspirations might be seen as the cosmos having those feelings in microcosm. As our journey through narrative comes to a close, it is worth sitting for a moment with the immensity of what we've touched. We explored the far reaches of galaxies and the deep recesses of atoms. We sailed with ancient navigators and listened to the sky's stories. We contemplated logic and myth, drifted through dreams, and finally looked within ourselves as though peering into a cosmic mirror. Through it all, a single thread wins. Connection. Everything is connected, perhaps not visibly or tangibly, but through resonance, pattern, and shared origin. It leads us to a gentle truth. The sense of separation is to some extent an illusion, and to be alive is to be a part of something vast, eternal, and yet intimately here in each moment. We have journeyed far in this exploration, sailing from the birth of stars to the depths of subatomic particles, from ancient myths to future dreams, from the outermost galaxies to the inner landscape of the soul. Through it all, a pattern emerges. Everything is interwoven. The atoms in our bodies link us to long dead stars. Our stories and science together illuminate the same cosmos. Our dreams at night echo the creative forces of the universe. Even our solitary mind is a microcosm reflecting the whole. It is as if the universe has been holding up a mirror, and in it we see not only the cosmos, but also ourselves. And perhaps that mirror works both ways. When we peer into ourselves, we catch a glimpse of the cosmos. In recognizing this unity, we find a kind of comfort, a sense that we belong here, that we are a natural part of the grand design, as fundamental as a moon orbiting a planet, or a thought orbiting the mind. Now, gently bring your attention to your body, allowing the tranquility of your mind to wash over every part of you. Notice how you are supported by your bed or the ground beneath you, by the earth itself. The planet's gravity is like a caring hand holding you safely in place. Take a slow breath, and as you exhale, imagine any tension in your feet dissolving into the ground. Your toes and soles soften and your ankles loosen. With the next exhale, feel your calves and knees release any tightness, your legs becoming comfortably heavy and warm. Breathe again and let go of any holding in your hips and lower back. The earth is cushioning you. You can surrender your weight to it. Let your belly relax and your chest remain open as you breathe. Feel the steady rhythm of your heartbeat, steady and calm, like the gentle ticking of a cosmic clock within you. Allow your shoulders to drop, freeing themselves of the day's burdens. Your arms and hands rest easily at your sides, tingling with relief. As you breathe out once more, feel your neck and jaw unclench and relax. Your face softens and your eyelids grow heavy. From head to toe, a wave of ease flows through you, as if a stream of starlight were washing gently over your body, coaxing every muscle into rest. Finally, as you prepare to slip into the gentle refuge of sleep, release any remaining worries or thoughts. There's nothing you need to do now, and nowhere you need to be, except here, in this peaceful moment. You are cradled by the cosmos itself, as you have always been. From the moment you were born, every atom in you has been kept in the delicate balance of forces that govern the cosmos. Gravity holds you to Earth and keeps the Earth circling the Sun. Electromagnetic forces keep your atoms together and also generate the light by which we see the stars. Nuclear forces lit the stars that made the elements that became you. The universe has collaborated for billions of years to bring you here now. In a very real sense, you are the universe, in one of its many creative and conscious forms, saying hello to itself, feeling wonder at itself. So, rest now in this knowledge. The cosmos stretches far beyond, full of mysteries and marvels, and it also curls up inside your very being. The journey of discovery is endless, but there's no rush. We have eternity, in a sense, each of us playing our part for a time. As our spoken journey ends, the real journey goes on in every moment, awake or asleep. We close our eyes now on the outward scene, but the inner universe will light up with its stars in dreams. May your dreams be gentle and filled with the quiet grandeur of the cosmos. And when you wake, may you carry a bit of this starlit peace into your day, remembering that beyond the hustle of life, the cosmos and your soul move together in an ancient and endless dance. Good night and sweet dreams under the eternal sky above.